Hello, good morning. Dr. Hemanta Medi, can you hear me?
Hello, yeah, I can hear you. Thank you.
So I think we can start the session. It's already over 10. So I'll introduce Dr. Hemanta Medi first. Uh, Dr. Hemanta Medi is presently an assistant professor in the Department of Civil Engineering, Tezpur University. He did his B from Assam Engineering College, and then he did his MTech and PhD from IIT Kanpur. He has several years of experience in the construction sector, in the R&D field, in the academics. I mean, he has worked in so many companies, including when he started his career, he worked in Punjloit. Then he was also working in the IIT Guwahati as JRF in the Water Resources Department. He has also been assistant professor in Adani Institute of Infrastructure, and finally he's in Tezpur University. His work basically focuses on prediction of flood magnitudes in the ungauged basins. His specific areas of interest are regional flood frequency analysis, regionalization, prediction of ungauged basins, flood modeling, flood scaling exponents. So basically, he has been working on the river flow modeling, flood analysis, etc. So it's a vast experience in this field. So I think so many years of experience. I'll say probably more than 10 to 15 years of experience in this particular field. So in this field of statistics, in the field of regionalization. So I think it will be good that he'll share his knowledge with the participants, and participant will be really benefited from his experience and knowledge. So, without wasting much time, I'll invite Dr. Hemanta Medi for the talk. Sir, can you please start the session?
Thank you so much, Dr. Pramodji, for that
Thank you.
introduction. It was kind enough from you. And I like to, say good morning to every one of you present for this talk and welcome you for this session. My slide, is it visible?
Yes, it's visible and perfectly audible. You are audible perfectly.
Yeah,
Yes.
I'll just, go through the slide if it is working. Is it working?
If you're changing the slides, it's not working. So probably there may be some issue with the slideshow. It happens sometimes in the MS team. Now it's changing. Now it's changing. Yes,
Yeah, maybe when I'm in the slide show mode, it's not working,
it
it
happens.
seems.
Yes, it happens. Yes, sometimes. So what you can do is you
So
can zoom into this in this normal mode, and then we can continue with this like this.
is this okay?
In the slideshow mode, it won't work, I think. So in this mode only, we can continue in the PowerPoint normal mode.
Okay, fine.
Uh,
Okay, then if it is visible, then shall we start?
Yes, yes, please, sir. We can start.
Okay. Well, as you know that most of the work in hydrology, it revolves around flood. And with flood, there are certain questions that comes to our mind. The first question is, like, are flood preventable? The environment that we live in, we cannot be 100% sure that we'll be able to prevent a flood, because if we do, some mitigation work, it might so happen that, because of the changing in the environment, the climate change, some or the other effect will squeeze in, and because of the interaction, we might not be, able to prevent a flood for 100%. However, if we have certain knowledge about the flood, then that might help us in making some mitigation work so that the damage caused by flood is not more. So this brings the second question to our mind, that are flood predictable? Now prediction has different aspects. Prediction in time, कौन से समय में होगा, prediction in space, कौन से जगह में होगा, and prediction of the magnitude, कितना मात्रा में होगा. So these three are the most important predicting parameters that we are associating with flood. So you can see a word cloud in my slide where I have written about precipitation estimation, river flood, inundation. These are the word cloud that is often associated with flood, and we often want to know more about it because these are very intriguing terms. And in this particular presentation, I'll be discussing about a framework in which we can estimate the flood quantile by incorporating the stream network connection. So, well, those who have just recently, just now joined, I'm Dr. Hemanta Medi, and I'm an assistant professor in the Department of Civil Engineering, Tezpur University. To move on, let's try to know what is flood. Every river, it has got a certain carrying capacity. It's the capacity of the river to accommodate flow within it, right? Now, for certain reason, which we'll be discussing, if the flow is more than the carrying capacity of the river, or the stage of the river is more than, you know, the usual flow stage that we have, that will lead to overspilling of this flow out of the river, and this will inundate the, you know, cities nearby or any places nearby, and this is flood. And with flood, you know, we have the miseries, economic losses. There are loss of many kind, and most importantly, the losses after the flood, and that is in terms of, you know, diseases that are spread. So why this flood happens, if we really want to know, you know, there are different, you know, inputs to it. Either it can be because of the rainfall, or some floods it may be because of the melting of snow. Now mostly in Indian context, if we discuss, you know, the monsoon region is the monsoon period is from, you know, June to October. So it is the time when we have heavy downpour of the, you know, rainfall, and at the same time it is this time where the temperature also rises, and, you know, to the rivers which are, you know, fed by the Himalayan ranges, mostly Ganga, the Brahmaputra river. It's the, you know, accumulation of both the snow fed as well as the rain fed that overspills the, you know, carrying capacity of the river. As we all know that the average annual rainfall is 1170 mm, and 80% of this, you know, quantum of the rainfall is during this June to September. The annual flow in the river in India is about 1,869 billion cubic meters. So we can see, you know, the magnitude of the flow that we are actually dealing with. Now, this flow, when it, you know, comes or flows through the river, because of certain characteristics, the physical characteristics of the catchment, and the interaction of these physical characteristics to the storm event, you know, there will be different responses. Now, this flood, it may be because of some natural causes as well as man-made causes, which we'll, you know, discuss in the later slides. But before we move in, let's, you know, see about the Indian, you know, the total geographical area of India, which is around 329 million hectares, and flood prone area out of this is 40 million hectares. So this I have got it from the National Disaster Management Authority. So as you can see, it's about 12% of the total land mass that is affected by the flood. But the problem is, you know, as civilization, we have always learned to live around the river area, right? Because that helps us in, say, businesses, agricultural activities, transportation. So time immemorial, if you see, you know, like Allahabad. So these are, you know, historical places that have evolved around the river. And because of this reason, the population density along the river is more. And although it's 12% of the area that is affected by the flood, you know, the quantum of, you know, in terms of economics, if you see, it's very high. Just to give you the figure, the average annual flood damage from 96 to 2005 is 4,745 crore. And previous to it, you know, in 53 years of annual average, if we take previous to this period, was 1,805 crore. So we can see that, you know, the increase in the, you know, flood losses, this might be because of various reasons, but then we can see the quantum, it's increasing. The life lost, average life lost because of flood is around 1,600 approximately in India, and the highest being 11,316. That was in 1977, the flood in the Andhra Pradesh because of the cyclone. So the flood, as you can see, it creates a lot of damages and havoc, and that is one of the reason why a study for the flood is quite important. This is another, you know, image from the National Disaster Management Authority, where you can see the red color, which signifies here, if you can see these red zones, these are the flood, you know, affected areas. These are the areas liable to flood, and most of it, you know, you can see in the northeast, which is the Brahmaputra plain and the Ganga plain along this northern India. Also, there are few pockets which you can see towards the Bay of Bengal, which are mostly affected by the coastal floods. Now, before we get into it, let's just, you know, take a brief look how, you know, what are the physical characteristics and what are the parameters that we look into flood. When rain falls in any catchment, this rainfall basically interacts with the physical characteristics of the catchment. What are the physical characteristics? These are basically the storages, the drainage density, the land use, land cover, the soil characteristics. So because of this interaction, it gives rise to a a plot of the discharge with time, which is the response. Now this response is known as the hydrograph, and the most important parameter in this hydrograph is this peak. So as a flood engineer or someone who is researching in flood, the most important parameter we are looking for is the flood peak, because this is the one which you try to negate during our studies. Now how this can be estimated, these peaks, there are different several methods. Out of this, the most usually used are the rational method, the empirical method, the flood frequency method, or we can also do modeling of floods. I'll just quickly go through the rational method and the empirical method before we dive into the framework that we'll be talking about in this today's presentation. So rational method is quite a simplistic form of finding out the peak discharge, the peak flow, which is given by this formulation: QP is equal to CIA, where C is the runoff coefficient, and it will depend upon the the soil type and the surface slope. Depending upon that, we have this C. I is the rainfall intensity, and A is the catchment area. And this rational method is usually applicable for area which is less than 50 kilometers square. So there is this limitation. However, this works very well if you want to have a quick peak flood estimates about a region. In various parts of the world, empirical formulas has been derived, taking into account the data, the flood data and the area of the catchment. In several places this empirical formulation has been derived. The most famous in India is the Dickens formula, which was derived in 1865 for the the northern area, which is QPCD A to the power 3 by 4, where QP is the maximum flood discharge and A is the area. So we can see this discharge, the flow in the river, this is scaled to the area to the power 3 by 4. Now this, you can see that this is a power law where the power is 3 by 4 to the area, and this power is known as the flood scaling exponent. And this is a very important parameter, and we'll discuss again about this in the upcoming slides. Reeves again in 1884, he derived this formula: QP is equal to CA to the power 2 by 3, where the scaling exponent is 2 by 3. So these are various empirical formulas around the world, and these are the few of the formulas. There are many more formulas, empirical formulas, relationships. So if we compare this empirical relationships, the scaling exponent, if you go through it, we can see we can have a scaling exponent as high as 0.833 and another scaling exponent of 0.5, which was used by mayors in certain areas of US. Again, you can see Fuller in US, he tried for different area and he got the scaling exponent as 0.80. So depending upon different regions, depending upon the interaction of this rainfall to the physical characteristics of the catchment, the scaling exponent varies quite significantly. Now, what could be the reason behind this different scaling exponent is a very interesting thing, and we'll try to find out if this scaling exponent has any relationship with the physical parameters of the catchment. So the earlier two formulas were basically based on the data that we have. The another way of finding out the flood quantile is a probabilistic method, where we try to fit distribution to the data we have. Now if we look into this particular figure, there are 5 catchments: A1, A2, A3, A4 and A5, and in every 5 catchments there are discharge data available to us. So if the discharge data are available to us, and suppose we want to construct a dam in this area A1, and we have this discharge data for say 100 years, what we can do is we can easily fit this data to a distribution which most closely fits the data, and depending upon the distribution we can have a flood quantile estimate depending upon the return period we need it. Suppose we want to design our structure for a 100-year return period. depending upon the the PDF that we have fitted to, we can easily calculate the 100-year return period and design the structure. We have an estimate about this flood. So few of the methodologies that are used are the plotting position method, and a generic form of an flood frequency analysis quantile is x equal to x bar plus k into sigma, where x bar is the average flow data that we have, sigma is the standard deviation, k is basically the frequency factor, which might depend upon the characteristics of the data, like the time period, the range of the data set we have. Now there can be one problem in this method. Suppose we have these 5 catchments like the previous one we have discussed. However, in the catchment A5, suppose there is no data available. Now this is quite a common scenario in India, right? Because suppose there is a region in a Himalaya remote places, and we want to construct a bridge there or a dam there. But so far, if suppose no data has been collected, there is no data at all, or suppose the site is just newly constructed, maybe 2 years back the data management system has taken into places, so we have just 2 years of data. So if you want to construct a dam in that place, a 2 years data will not be possible. Or suppose there is no data, it will never be possible to have a estimate of that place if you want to get it from a data, right? So in that case, a regional flood frequency analysis, these techniques come into picture. What we basically try to do here is, if A5 in this area, the catchment A5, if there is no data available, we try to find out few catchments in the neighborhood which are similar to the catchment A5. Now, if that is similar to this A5, we call those catchments as homogeneous. So what does this homogeneity means? Homogeneity means that if the flood characteristics of this catchment A5 is similar to somewhere around A2 or A3, then we say that A2, A3 and A5 are the homogeneous catchment, and these catchments together are known as one cluster. Now in regional flood frequency analysis, what we do is we try to pull the data from this homogeneous catchment. So in this A2 and A3, if they are similar to A5, the data is available at A2 and A3. We'll try to take this available data which is homogeneous to A5 and use this data to find the estimate at A5. So this is known as regional flood frequency analysis. And the steps for regional flood frequency analysis starts with collecting the data of the places or the catchments which are known or which are homogeneous. So in the first step, we try to collect as many data that is available. So for example, the flow data, this flow data will be available to all the sites except for the site where we want to make the estimate. Physical characteristics or the physical attributes, these are the attributes like the area, land use, land cover, like the forest area percentage, the urban area percentage, the drainage density. Meteorological attributes, these includes the rainfall, precipitation, the temperature, humidity. These physical attributes and meteorological attributes are mostly available for all the sites, but this is the flow data which is are difficult to get, and this is why this regional flood frequency analysis is helpful. Now once we have this data available to us, based on the physical attribute and the meteorological attribute, we try to cluster them, try to find homogeneous catchments. Once we have the homogeneous catchments, say we group them into k number of groups, k number of clusters. So in every cluster, in every group, we do the frequency analysis and have relationship between the flow and the attributes. Now suppose the sites that we are talking about where we don't have the data, the A5. If A5 falls very close to suppose this F2, then we'll use this relationship that we have developed for F2 and we'll try to find out the estimate. And once we have this estimate, we can do scaling studies. Now, before we move on, one of the hardest part here is the finding out the homogeneous clusters. Now let us take an example. We can see in the screen there are 5 fruits. We have strawberry, we have apples, we have pomegranate, we have the oranges, and then an mango. So for someone who knows which is what, we can easily cluster them into group. But suppose a alien has come from the planet Mars, and we give these 5 fruits to him, and we say that cluster this into 2 groups, or maybe 3 groups or 4 groups. For him it becomes very difficult how to group them into different groups. So based on the color, he can group it into 2 clusters, because the strawberry, the apple, and the pomegranate, they are red in color. He will put it into red basket, and the oranges and the mango, these are somewhat yellowish orangish color, so he will put into one bracket, the basket. So with respect to color, it will be 2 groups. However, if he takes into consideration the shape, he might have a different clusters, or if he takes the size, he will again have different clusters. So clustering is often a very difficult problem. Now, which cluster will be suitable for us? And again, if we combine all the 3 attributes like the shape, color, and size, depending upon the combination of the attributes also, we might have different clusters. One of the important thing that we often do at the end of our semester, right? While grading our students, we usually have the marks, and we want to cluster them into groups to give them A grade, B grade, C grade. But it is often difficult to give, to put the margin where we should exactly put the margin, so that we can differentiate between this A grade and the B grade. And similar is the case for this catchment. How do we put which catchments to fall in which particular clusters? So to put them into clusters, there are different methodologies. One of this method is the global k-means method. In global k-means method, what we essentially try to do is we try to make the clusters as close as possible within itself, but as dissimilar or as different as possible between 2 clusters. So within the cluster it should be as close as possible, and between the cluster it should be as far as possible, and the objective function f is given by this formulation. So one of the simple techniques to do this is suppose we have this particular figure on the right side, the first figure. There are 3 essential clusters that we can see with our visible eyes. Now it is very easy to see in this case, because we have spread the cluster in a 2-dimensional coordinate. Had it been in a different n dimension, suppose, it will be very difficult for us to see with our eye. Now for this case, what we can do is since we know that there are 3 clusters, visually we can have an initial 3 clusterization. So 3 initialization. So these 3 red dots that we can see, we can take these 3 red dots as the initial cluster mean. Now what we do is we'll take any point and we find the distance of that particular point to all these 3 initialization means. Whichever the distance is less, what we do is we will put that particular point in that particular cluster. So suppose we have this 1 red point, 2 red point, and the 3rd red point, and we take this blue point at the edge. Now we will measure this distance of this blue point to the 1st red point, the 2nd red point, and the 3rd red point. To whichever the distance is least, we'll put that point to that particular cluster mean. Once every point has been assigned to the first initialization mean, then what we'll do is we'll recalculate the mean of all the new points that we have done, and that will be shown by these green points. And then we'll keep on repeating this till there is no change of this particular blue points to any of the initialization means. Till then we'll keep on doing. And since there are 3 parameters in this particular methodology: number of clusters, the initial cluster mean, and a distance metric. So usually the distance metric that we use is the Euclidean distance metric. However, we can use any other metric that we want. Now this particular method that we have already discussed, the global k-means, this is a compact based clustering method, and there is one problem with this. The problem is that it usually try to ignore the connection information between the the points, the data points. So the other methodology was given by Zelnick, Manor, and Prerona in 2005, and they named it as the self-tuning Spectre clustering method. In this method, they try to, give weightage to the affinity between the points. So what it usually does is it, basically starts with calculating an affinity based matrix, which is given by Aij. Now each element of this matrix Aij is given by exponential of d square Si Sj divided by lambda I lambda j, where this lambda I and lambda j are the two parameters. Lambda I is the parameter of the ith station, and this is basically the distance between the ith station and its nearest neighborhood. So this nearest neighborhood is the another parameter. Similarly, if we want to find lambda j, that will be the distance between Sj and its nearest neighborhood. So once we have this affinity based matrix, we find out the eigenvectors, and on the eigenvectors we basically perform a clustering analysis. The advantage is this because we transform the coordinate, the axis along the direction of the maximum variance, and that helps us in basically getting the clusters more easily. So this is the advantage of this particular methodology. Now, most of the studies have used the global K-means method. But if we look into the real hydrological data, we can easily see that the hydrological sites that we have, these have connection between them, and the connection is essentially the stream network. So Ganga flows from the Himalayan ranges through the plains, and it reaches the Bay of Bengal through Bangladesh. It's a transboundary river, right? Now, any point that lies in this Ganga river, this has certain connection in between. Now, this connection can be stronger if they are nearer to each other. However, if the distance between the stations are very far, the connection will be weak. So we try to formulate this, and we hypothesize that if the connection is strong based on this, the river network, stream network, we should give certain weightage to this, this particular information that we have. Till earlier, we worked, this information was not given any weightage during the clustering part. Although there were some ad hoc based measurements where, once the estimates were done and then the ad hoc based methods were used, but during the clustering framework, this particular information was not given any weightage. So we decided to give weightage to this information, and let's try out. And at the same time, the clusters that are in the hydrological sense, it might be at different scales as well. By different scales, what we mean to say is that some clusters may be very tight, and at the same time, the clusters may be sparse as well. Also, one cluster may reside within the another cluster. That might also happen. So thinking about these different scenarios, we first try to compare the GKM and the self-tuning spectral clustering algorithm to the hydrological network. So we started with this synthetic data. So at the top we have the spiral method, and at the bottom we have the circular method. So by naked eye, you can clearly see in the spiral method there are two spirals, right? One is the inner spiral and the other is the outer spiral. If we use the GKM method, which is the second figure, the middle figure, we can see that it clearly divides the data set into two equal parts. Now, this is because of the nature of the objective function. As we have said, this is a compact based clustering algorithm. It tries to take as compact cluster as it is possible. In such scenario, the self-tuning spectral clustering outperforms the GKM. Here we can see that the two clusters are very nicely, segregated. The similar case is seen for the circle as well, the two concentric circles. GKM fails, but the STSC method easily, identifies the two clusters. So we can clearly see that as the river data set we have, it might not be a compact based cluster, right? Because of the connection. So we can argue at this point that because of the connection system, the connectivity should also be given a weightage. Now, the other part is once we have this cluster, we try to find out the flood data. So as we have discussed, basically, we use the power relationship that we have between the discharge and the area, where beta is the flood scaling exponent, and the H side analysis is done by fitting the data into a PDF, and we get this generic form, which we have the estimate is equal to Q bar plus ZT into sigma. Now, we use Wisconsin area where we had 305 gauging sites, and all these 305 gauging sites were unregulated streams. The average record length of these sites were 40 years. First, we tried to find clusters of this particular area from 3 to 8. So we did clusterings starting from 3, 4, 5, 6 and went up till 8, and we trained the data to have the to see the performance. We took 70% of the data for training and 30% of the data for testing. So here you can see this is the Ohio region, which is basically in and around this Indiana, Kentucky, West Virginia, Pennsylvania, the Lake Erie region, and the Michigan region, where there are few stations out of this Ohio region as well. Apart from this Ohio, we also use this methodology in Texas, Indiana, but for this particular presentation, I'll be showing the results of this Ohio only. So the attribute that were available to us were these 13 attributes, where we had the latitude, longitude, the drainage area, the main channel slope, the sum of the the open area, the wetlands, the climatic factors, circularity ratio, the precipitation. All these 13 attributes were first used in the clustering algorithm to cluster the groups based on the watershed attribute only. The discharge data was not used for clustering. The reason, as we have said, we want to have the cluster only based on the watershed attribute, so that we use this data to estimate the discharge, because there can be certain areas or catchments where the discharge data will not be available to us, or the discharge data might be very scarce. So because of that reason, the discharge is not used while clustering. What we try to do is we use the watershed attribute and then try to predict the discharge based on the clusters, and try to see how good the performance is based on the clusters due to the k-means and the STSC method. So the parameters, as we have discussed, the lambda and lambda j, which depends upon the nearest neighborhood. This is the training data set. We varied the nearest neighborhood from 0 to 300, and we did this training, and we got this training data set. Okay, so in this training, what we can see is that the continuous line is basically the STSC method here, and the dotted straight line, that is the global k-means method. We can clearly see that there is a region of nearest neighborhood which is very less value. Here we can see that the STSC method is better than the GKM method. So specifically in and around the nearest neighborhood of 7, we can see that the RRMSE is minimum. RRMSE is basically the relative root mean square error. We also had this absolute relative bias. Here also we can see that where the nearest neighborhood is around 7, we can have lesser value of the error while compared to the GKM. Now, once we have these two clusters, we need to figure out if the two clusters that are formed, how similar or how dissimilar the clusters are because of the GKM and the STSC method. For this, we use the methodology given by the Hubert and Arabi in 1985. So this method basically takes into account the total number of sites. Suppose there are 2 clusters, we try to find out how many sites are there in cluster 1 and not in 2. Again, how many are not in 1 but in 2, and finally how many are both in 1 and 2 of the different cluster algorithms. And based on that, we have this index which is known as the ARI, or the Advanced Rand Index. Now, this advanced RAND index for different nearest neighborhood was also plotted and shown by this red line. So here we can see that when the nearest neighborhood is 7, the RAND index is around 0.6, which means that the clusters that is obtained by the two different methods are different. We also plotted the heterogeneity index to see how homogeneous the clusters were. We can see for the nearest neighborhood of 7 also the heterogeneity index is quite less. So depending upon these two tests that we have done for the error and this heterogeneity index, we took the nearest neighborhood as 7 and we continued our study. So depending upon the nearest neighborhood of 7, we had these two basically clusters. The figure on the left, A, is obtained from the GKM, the STSC method, the self-tuning, self-clustering method, and B is from the GKM method or the global Cambridge method. We can see that there are certain differences in the two clustering algorithm. So KA, these are basically the pink triangles that you can see. These are spread across from east to west here. However, in the STSC method, the GKM method, we can see these are concentrated only in this region, which is basically the Appalachian Plateau. This area where we have the blue diamonds, this is the K6. This is basically the plain, the northern plains. So we can clearly see that there are differences in, although they are similar, but there are differences when you look into the clusters that is obtained. So having a closer look on the clusters, we found that the size of the GKM that was formed for 8 number of clusters are as follows, where the minimum size of cluster was the 7 clusters, where the value is 548. And for the STSC, the minimum size was for 2, which was 936. So thus, we can clearly see that there is a difference between the cluster sizes that is formed between both the methodology. Now we compare this both the clusters based on the testing data set that we have. We try to estimate the flood quantiles for 10-year return period, 50-year return period, and 100-year return period. For GKM, we can see that for ARB the value is 40.99, and for the STSC we had 35.57. So we can clearly see that there is a decrease in the error that we have. Also, we tried to take only those sites which had more than 50 years or more records, so that we had more confidence in our analysis. There also we can see that the ARB of the GKM was quite higher than the ARB of the STSC method. So on the bottom, we can see the histograms, where you can clearly see that the yellow is the histogram obtained for STSC method and blue is the histogram obtained for the GKM method. Comparing both, we can see on an average 25% improvement because of the consideration of this STSC method. Now, to understand as to why this improvement has taken place, we tried to find out the range of scales of the clusters that are formed. The range of scales basically give us an idea about the cluster formation, physically what is happening inside the cluster. If the range of scale is high, that means the clusters had both tight clusters as well as sparse clusters. But if the range of scale is less, that means most of this cluster that are formed, these are tight clusters. So in this figure, if you see, for all the 13 attributes that we have, the yellow line is higher than the blue line. That means the range of scales of STSC is more for all the attributes except for the drainage area and the channel slope. For this, they are almost comparable, but apart from these two, everywhere we can see that the range of scale of STSC method is high, which signifies that the clusters formed are having both tight clusters as well as sparse clusters. So this is one thing which helps us to understand, or gives us an indication that the hydrological data sets resides in groupings which can have both sparse and tight clusters, and if we are able to identify them, we can have the estimates with lesser error. Now we try to introduce our framework to this, methodology that is there. So our hypothesis, to understand our hypothesis, let's look at this slide. We can see that there are three basically gauging sites, 1, 2, and 3. Now, if I ask anyone, for a simple, sake, say, if I want to group this 1, 2, and 3 sites into two groups, what will be the two groups? Quite obvious, people will, it's a tendency with this particular attributes only, we'll try to select 1 and 2 as one group and 3 be to a different group because it's far. However, if we have this information where we can say that 2 and 3 are connected by this streamline given by this blue line, this is a river. However, 1 falls to a different river. So we can clearly see that 3 and 2 are connected, but 1 is not connected to 2. Now again, because 3 and 2 are connected, that means a part of this catchment have an overlap between both. So the catchment of 2 will have the catchment of 3 within itself as well. And this we name this variable as RA. Okay. So this is basically the ratio of the overlapping watershed. So this ratio should be used in a certain sense so that the clusters can be modified. So we use this hypothesis to see in a region of the Ohio. So in this figure we can see on the left hand side, these are the stream network where 198 and 197, these are the two sites which are connected by the stream. However, 131 is another catchment or a site which is not connected. Now if we want to use the clustering algorithm which is previously used, only attributes are used. So if we use the attributes, we have this figure at the bottom. Black color means that both these catchments are closer to each other. So we can see this matrix, this element is gray in color, 131 and 197, which means that 197 and 191, they are closer than 198 and 197. So 198 and 97, although they are connected by the stream, they are different. The answer will be different when we use only attributes. Now, if we use the PDF of this particular stream, we can clearly see now that this was white when we use the Euclidean distance for the watershed attribute, but this became dark in color, this element, when we use the PDF information. And this information which was dark earlier, it becomes light in color. Now this matrix was obtained by the Janssen and Shannon distance, which is a derivative of the Kullback-Leibler divergence. So we can clearly see that when 198 and 197, these are connected by the the streams, and when we take the information of the flood, the PDF, they become closer. But when the attributes are there, they were different. So this gives us a merit in this particular framework that this is a very important information and this should be used. So based on this, we modified the earlier clustering algorithm where we give then weightage to this RA ratio of the ratio of the overlapping areas. So the initial Aij, which was in the spectral clustering, to this we multiplied 1 minus RA to the power W plus RA to the power Ij to the power W. So this R is the ratio of overlapping area when we are giving a weightage W to it. So we try to figure this out, and depending upon this particular weightage that we have given, what we are basically trying to do is we are giving weightage both to the network connection as well as the attribute. So depending upon different scenarios, if weight is equal to 0.5, we get this kind of a figure on the left, which says that the combined affinity is given more preference than the attribute affinity. Now when W is equal to 0.5, when W is equal to 5, the weightage is equal to 5, the combined affinity and the attribute affinity are similar, although for few sites they are not same. And when we increase the weightage very high, then almost all the weightage is given to the attribute affinity, and the combined affinity is not given any preference. So we have to try to figure out in between this first figure and the second figure, we need to figure out where is this threshold, where is this W, where we can give a combination of the affinity between the attribute as well as the stream network. So this is another way of looking into the combined affinity and the ratio area. We try to vary the ratio area for different weightage, and along with the different weightage, how the combined affinity would vary. And this is how the figure look like. On the right hand side, we can see when the weightage is from 5 to somewhere around 27, the ARB, the error was almost minimum. So it gives us an idea that when the weightage is in this range, for this particular data set, we can say that the error would be minimum. Now, based on this, we continued our analysis and we saw that because of this network information incorporation, we could see for different experiments a further reduction in the errors, as high as 60% for experiment 1 and as low as 7.58% for experiment 4. Now 1, 2, 3, 4, this experiment basically considered the combination, different combination of the attributes and the connectivity information. So when the attributes is minimum and the connection information is high, that is 1, we have more improvement in the error. And when we have more attributes and combined with the connection information, which is the 4th experiments, we had the least error. So this study basically gives us an idea that for places where we have less attribute data, our methodology will give better results. However, if we say that 7%, some may argue that 7% may not be that much helpful. But if you look into the flood quantile, when you go for a construction, a 7% improvement in the flood quantile estimation will have a significant impact in the cost reduction of the structure. So that way, if we look into this picture, this will have a quite an significant impact in the flood structures. Now, once we had this, we wanted to see the scaling exponents. So the power law that we had, Q is equal to alpha QT to power beta. That beta was the scaling exponent that we had discussed, right? So this scaling exponent, how they vary, we wanted to look it for the conterminous United States. So in United States, in USGS, they have different water resources regions, 21 to be specific. So we considered only the conterminous United States, and we left out this 19, 20 and 21 region. And for all this region, we tried to find the heterogeneity index. Now if heterogeneity is more than 3, it is usually considered as a heterogeneous site. If it is less than 3, the index, if heterogeneity index is less than 3, we call it as homogeneous. So based on the demarcation of this water resources region, the figure on this top right hand side, we can see that most of the area is heterogeneous. Now if we find the flood estimates based on the earlier methods, the figure on the right bottom, this gives us the flood exponents, where we can see that on the east side the flood exponent is high. As we move towards the left side, towards the west side, it decreases further, and from here it keeps on increasing. Now where it decreases, this is basically the Mississippi River. So along this region there is a decrease, and on either side it starts increasing. Now these are the earlier methodology used to find out the scaling exponent. So we devised a methodology where we wanted to see if we can attribute every station to a scaling exponent and just try to figure out how these are connected to the the physical characteristics. For this, we use the region of influence method. In region of influence method, basically it is not a static cluster, it is basically a dynamic cluster where we try to take any site. So for example, if you look into this figure, A is one side shown by this triangle, red triangle. So we try to find out which are the nearest neighborhood which would be most homogeneous to it. For that, what we did was we used the L moments. Based on the L moments, we tried to find out which are the most nearest possible, homogeneous sites to this particular station A. If heterogeneity index was more than 3, then it would fail. Then what we will do is we'll reintroduce another site, do the heterogeneity test again. If it fails, we will keep on adding sites till the site passed. When the site passed, we try to find out the relationship between this particular flow and the catchment area, which is shown by this right hand side drawing, where you can see the log of the flood quantile and the area at the bottom, log of the area. And every station will be, by this analysis we will have different flood scaling exponents. Now this flood scaling exponents, based on stepwise regression method, we try to figure out which are the most important attributes which affects this flood scaling exponent. So based on this new methodology, we had flood scaling exponents for different return year period, like the 5-year, 10-year, 25-year, 50, 150-year return period, and these are plotted on the right hand side. So if we look into both the figures, to the left this is found by the traditional method, and to the right this is found by our methodology. So here also we had the same kind of the trend. So it's high on the eastern side, it decreases and then increases, similar to what it is. However, every side, if you see the value, we can get more clearer picture of the side information. So here, like any side which should be in 2, this will have only one scaling exponent. But here we can have multiple scaling exponent based on the region of influence method. Now, once we had this based on the stepwise regression method, we had this box plot created with respect to the most important or the variables that were influencing the scaling exponent. So what we can see in this box plot is, see, we have plotted this temperature, potential evapotranspiration, the water content, the clay content. Based on these 4 variables, what we can see is that the blue colored box plot is higher than the red color. That means blue color is basically having higher value of losses than the red one. And what is this blue color? This is basically the flood exponent that we have for every size. They are being grouped into 2 parts, high scaling exponent and the low scaling exponent. The low scaling exponents are denoted by the blue color. The red color is being shown to the high scaling exponent. So in this particular box plot of these 4 particular attributes, we can clearly see that if scaling exponent is blue, that is low, then the losses will be high. However, on the right side, if you see the Hortonian overland flow basically says that most of the flow is overland flow, right? So when most of the flow is overland flow, then we can see that this is a low scaling exponent. So if it is a fast catchment, then the scaling exponent will be low. Similarly, if the base flow index and there are forest areas which will basically put hindrance to the flow, the physical characteristics, this shows that the scaling exponent, when these are high, when these values are high, then the scaling exponent is also high. So whenever the catchment is fast, the scaling exponent will be high. We also try to figure out what if the flow in the rivers are snow fed or rainfall fed. Okay, so to the top we can see the standard deviation of the scaling exponent we have plotted on the top left side, and the bottom right side we have plotted the percentage of snowfall out of the total precipitation. So higher value signifies that this receives more precipitation as snowfall, and blue color means it receives more precipitation as rainfall. Now if you compare both this figure, what we can see that wherever this is blue, here this area is blue and this area is red. So if it is rainfall, then the standard deviation high. Standard deviation high, this means this is multi-scaling. Again, this is also blue, but this color is red here, the standard deviation high. So it basically, we can see that whenever it is rainfall, we can see that it is multi-scaling. Now, when this is red color, that means this is mostly snowfall. We can see blue patches here. So when it is mostly snowfall, we can say that this will be having lower standard deviation. That means it is simple scaling. However, the middle region, if you can see this particular area, which is blue here, so this is also blue in this region, this particular area, and this area is from the Appalachian mountain. So this Appalachian mountain hills, when we basically try to look into it, we found that these are both snow fed, and during the summer season the snow starts melting and also rain takes place. Because of the combination of both the snow and rainfall, somehow these are disproportionate in this figure. If you can see, these dots are basically from this Appalachian mountain region, and these are the region which does not show this particular property. However, the other part we can clearly see it shows the property. So there is a trend, decreasing trend of standard deviation with respect to the snowfall percentage. And this is, we try to classify the data. In classification we found that based on the moments, we can see that 78% accuracy, within 78% accuracy we can find if the watershed is a high scaling exponent or a low scaling exponent. We also tried to do this with the limited data that we have for the Ganga region, and for the Ganga region also we had similar answers, or the similar results were available. However, this is, if we have more data set, we can in details we will be able to study about this Ganga region. And with this, I like to end today's talk. We are already time, with one question to you. Looking at this slide, how many clusters can you see in this particular figure? Well, it's a very easy question, but a very difficult answer. Now, if you look carefully, some of you may say that there are 2 clusters. Some of you may say that there are 3 clusters, and some of you may say there are 6 clusters. Now, clustering is, like the alien trying to figure out different fruits. Same is our case when it comes to the hydrological data set. It becomes very difficult for us to basically cluster them based on only attributes. So more studies required to try to incorporate this physical characteristics, like the one one of it is the stream network information which we have tried, and many other this kind of physical attributes can be incorporated, and we can do it. Finally, I'd like to end with this saying by Bevan in 2000. Bevan in 2001 of his paper, he said that there remains the problem that we may never have the measurement techniques to characterize fully the actual properties in specific basin in which predictions are required, the very essence of a problem. Now, this is very important, because what he said is the attributes which are important for clustering, there is a possibility that we might not be able to find out all those attributes which we require. For example, if we are in a room and there are 100 people and we want to cluster them, somebody may use eye color, somebody may use hair color, somebody may use the place of birth. But which are actually those attributes that we use to get the true clusters? That might well not be possible if we are not able to find out the actual attributes. Okay, thank you so much for patiently hearing to me. I hope I have been able to add something to you guys. Hoping you have liked it. Thank you so much. Thank you, Pramodji.
Thank you so much, Dr. Hemanta Modi. It was really an interesting session. I was there throughout your talk. Actually, you have connected, the dots using simple examples, and also, taking up the complex phenomena of this flood estimation using the frequency analysis and all. So I hope question will be there from the participants. So any questions from the participants, you may raise your hands and ask the questions if you have anything related to this topic. Any questions from participants? Okay, so I think right now there are no questions, and in case you have any questions, you can forward to us. We'll forward it to the to Dr. Hemanta Medi. And once again, I would like to thank Dr. Hemant Medi so much for sparing his time. He has a busy schedule right now. He'll be having another lecture in his institute also, so he agreed to that. So we are really thankful to on behalf of entire team of DAM 2020. We once again look forward to meeting you in personal. Okay, thank you, Dr. Hemant Medi. We'll meet soon. Thank you. Your voice is not audible. I think your mic is mute.
Thank you so much.
Thank you so much. Thank you so
Thank
much.
you so much, everyone, for patiently hearing to me. Definitely, in future, we'll try to collaborate and more on this topic.
Exactly.
Actually, yeah, I have another class, starting already
You
is
told
time.
me, yes, 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 you told
Yeah,
me.
yeah. And if there is any question, please do send it to me. I'll try to answer them individually and
Yes,
send it to you
yes.
back.
And I'll request you to forward me the PPT so that I can share it with the participant. That will be wonderful, actually.
Yeah, yeah, definitely, definitely. Thank you so much again. Thank
Okay,
you so
thank you
much.
so much. So now with us, we have our next speaker. Uh, so sir is with us, Dr. SP Rai, Dr. Shiv Prakash Rai. So I'll introduce. Sir, I'm audible, sir.
Yes, yes, you
Sir, so
yes.
I'll just introduce you to our participants. Dr. SP Rai sir is an associate professor in the Department of Geology Department. He is a professor of hydrogeology at BHU, Varanasi, India, since 2018. He has been involved in teaching of hydrogeology and research in area of water and environment. Prior to joining BHU Varanasi, he was associated with National Institute of Hydrology. We all know that NIH Roorkee, National Institute of Hydrology, as scientist F position since 1996, and we know that's a premier research institute under the Ministry of Jal Shakti. Jal Shakti, who doesn't know if he's working in the water field? Dr. Rai has gained research experience of more than 26 years, which is a lot of time, involving teaching, research, and capacity building and outreach experience. Further, he has also worked as team leader as well as deputy team leader in various multidisciplinary projects funded through international and national funding agencies, having more than 200 publications to his name, out of which 90 articles are in peer-reviewed international and national journals. He has prepared, this is very important, he has prepared more than 20 technical reports at NIH Roorkee to transfer the knowledge of his research work to government departments involved in water resource management in India. Further, he has also prepared a technical guideline on groundwater pollution investigation, which includes deep groundwater using isotope techniques for IAEA Vienna in year 2021. Dr. Rai was selected by International Atomic Energy Agency as an expert in an expert mission to provide training on application of isotope in groundwater resource management. In year 2021, he has also been selected as an expert to establish isotope hydrology laboratory in Afghanistan. So presently, he is also the founder member of the Australia India Water Center, launched to enhance collaboration in sustainable water futures between Australia and India with interdisciplinary approach. And Dr. Rai is also mentor on Australian Research Cooperation Hub, that is ARCH India. So with so much of the experience and field experience, teaching experience, there are a lot of things to say, but I stop here because we want to hear from him also. So SP Raj sir, I'll welcome you to
Okay,
give your talk on this topic. Sir, please.
okay. Thank you, Dr. Pramod Soniji,
Thank you, sir.
for this nice brief introduction, and and giving the opportunity to deliver this lecture on this important topic. So thanks, and now I am going to share my.
Thank you, sir. Sir, please, please.
Okay. So my PPT is visible to all of you.
Yes, sir. It's visible. Yes, sir.
Okay, okay, that's good. Okay. So as actually, I'm not knowing background of all the participants from here. What is the level of all the participants? So I have started to talk. I planned my lecture topic that I will cover the basic part also, so that nicely I can connect the isotopes. So
Yes,
why
sir. I'll
isotopes?
give you the idea, sir. Nearly 50% of these are masters and 20% are PhDs and
Okay.
30% are BTechs.
Okay, so that include all the categories.
Yes,
So
all.
I think I have planned a nice way. So just briefly, I will give the causes of floods and what are the processes which control the floods, and then what are the techniques which control the which are used to flood estimation. As in previous lecture already you have gone through that lecture, and then how the isotopes are useful and helpful to us to understand the flood, to not understand only, we can even estimate the flood amount and to know the process by which that flood has been originated. So all these we can know by the using the isotopes. So just one by one I will come on the topic. So keeping in all this, I have already briefly told you that what are my main topics: causes of flood and what are the processes controlling the flood, techniques available for flood studies, why isotopes are important, and what are the isotope techniques. And I have already worked on few case studies, so I will show you all these case studies also. So all of you know, because you are already having graduation level and PhD and postdoc level, so you know what are the floods. I'm not going in detail, but why the floods are important in our country? Because you know every year floods come, and government spends millions of rupees to manage that flood problem, even though that problems is again not controlled in such way that we are not in position to manage the flood nicely or properly. So that is a big issue for the government and the society to manage the flood problems in the country in a better way. Because if you see because why it become important, if you see the area wise. So out of the total geographical area, around 40 million hectare is flood prone. So that floods are a recurrent phenomena which cause huge loss of lives and damage to the livelihood, systems, property, infrastructure, and public utilities. So not only in terms of we are losing in terms of the economically, but we also losses the lives. And you know the flood causes all type of impact on the society. Some are the immediate impact, some are the long time based impact. So that overall it impact to the GDP of our country also, and total economic growth of our country also. So this is the reason why we should be able to manage the flood in proper way. So if you see what are the causes of floods in the country? If you see, so basically we can categorize in 4-5 type of the causes. What are the first one is the meteorological cause, by which if there is heavy rainfall and snowfall, then failure of dams and barrages, then landslide, if these landslides blocks the river path, then again it causes the flood after sometimes. Change in land use. So impact of change of land use already you witnessed. Nowadays we are seeing the urban floods. Then some hydrogeological characteristics which also control the floods, which are the drainage area and the geology. So it means the flood is not causes of, if you see the causes of the flood is not controlled by a single cause. So it is the response of whole catchment process. So it is interaction of the hydrologic, meteorologic, and topographic factors. So because if you want to manage a flood in proper way, so then you should know what is the factors which control the floods. So then we can go on the root cause, and we can prepare a better mitigation measures by which we can control the flood in our catchment area. So naturally, you know, all type of floods I have already discussed, but there is another new type of flood which has emerged as a major problem, that is Govt and anthropogenically induced floods, that is the urban flood. So these two types of floods are recently, we are in last 20 years we are now started to face. Earlier it was not a problem. So Govt क्या है? Govt है glacial lakes are formed by the melting of glaciers, and then that lakes suddenly discharge large volume of water and debris from the glacial regime. So that become a outburst of flood of Govt. तो ये Govt होता है. And now I'm coming to the process. Overall, अगर हम देखें, what are the basic processes which control the whole catchment in generation of the stream flow in the catchment area. So because the source is only precipitation, so precipitation is the only source. But what happens? After that, when the rainfall started, when it reaches to the Earth's surface, so here on the Earth's surface, many hydrological processes start. So overland flow, interception, surface storage, overland flow, discharge starts to take place through the soil. Some parts in the interflow starts, and some parts join to the groundwater and you can say aquifer, and that again it comes out in the river in the form of base flow. So overall, what happens? Whatever you get discharged at the outlet of your river, at your measuring site, so it is the response of all these processes. So that means if you want to know how much discharge from a certain catchment area, then you should know what is the amount of precipitation, what is the evapotranspiration from your area, and how much discharge has taken place. So if you minus all these from the precipitation, then you'll get the stream flow at a gauging site. So that is the response. Sometimes become in accumulative way. Sometimes it causes the flood. So overall, the process which involve, I have already discussed you. So that it means the overland flow, interflow, and base flow. All these three combines together, and these together makes the channel discharge, network discharge. So whatever the discharge you are getting at the gauging site, or you can say at any site, so then it decides that amount of volume of that flux decides whether river will be flooded or not. So it means if you want to know if you want to estimate about the flood and flood magnitude, then you should go through all these processes. If you are not aware all these processes, then it is difficult to estimate the flood at your gauging site. So naturally, if we talk about the flood discharge, so hydrograph is an important part, and all of you know about the hydrograph, so I'm not going much detail in that, but that peak flow and time of concentration of that peak flow, which is the important. So here because that is controlled by your geological factor, it would be controlled by your land use pattern. तो ये बहुत ही डिसाइडेड करता है किसी भी if there that time of concentration gets shortened. If overland process increases, then this time will be reduced and peak flow will will come at a very soon, in a very sooner way, and the amount of the peak flow will be the very higher. So that is the flood by which this decide the magnitude of the flood. By peak flow decide the magnitude of the flood, by which how much flooding will take place in the your catchment area. So it means whatever the discharge we are getting in a river, it is not a single component. It is not a single component. We should keep in mind that it is not a single component. It is a combination. It is a combination of the accumulative impact of the base flow, interflow, then surface runoff due to saturation condition, then the impervious and direct runoff. So it is accumulative discharge of all these components. Then it becomes a stream flow. So it means if you want to manage the flood, then it means you have to work on different components, and then you have to know. Then you should know how much amount you are getting in a river from a base flow, how much amount you are getting in a river from the interflow, and how much amount we are getting from the surface runoff, and how much amount we are getting from the change in the land use conditions. So any anthropogenic activity which causes the alteration in the catchment area. So what are the impact of that activity? So all these category we should be in position to separate out. Then only we can manage the flood in proper way. So, but it is not possible since till now that we can separate out all those components. Even I have forgotten one component here to mention: snow and glacier melt contribution. So if you take the example of in our case, because all the major rivers originating in the Himalayan regions. So in Himalayan regions, streams, because they are all the major streams are snow and glacier fed. So if you see the major component of our river discharge are, so there is three component. That is the direct runoff, that is the quick response of the rainfall to the runoff, then snow and glacier melt runoff, and then base flow. So these are the three basic major category by which the total discharge we get in a stream. Because interflow we can include in the base flow, that is groundwater or base flow. So change in land use we can incorporate in the rainfall runoff, because till now the techniques are not available that we can separate out all these components very nicely on a bigger catchment area. So here isotopes role starts. How we can separate out the different component of a stream discharge to understand the runoff generation process in a catchment. That is very important, because without knowing the runoff generation process of a catchment, you cannot advise what kind of mitigation measures should be adopted in the catchment area. So that is very important. If flood is causing because of the change in land use, then accordingly you will advise. If flood is because of the snow and glacier melt, then accordingly you will take measures. If flood is because of the base flow, then you will accordingly manage the things. So then it means you have to separate out, or you have to quantify how much contribution coming from the groundwater, how much contribution coming from the snow melt, and what are the role of the catchment characteristics, and then what is the impact of the land use change, even nowadays climate change. So that then all these things we have to understand in a better way. So then we can advise or we can prepare the mitigation measures accordingly for attachment, so that we can minimize the flood in the downstream sites. So different, now just see what are the different techniques to separate out the hydrographs. Classical engineering approach, which till now it is in the practice, where there is no discharge data, where there is no meteorological data. People are using this one-time discharge or one-time hydrographs, measured hydrographs. Even empirical equations are used to build bridges or culverts for the railways and roads in the different areas. So these techniques are still classical engineering approach are in use. Then modeling approach, already I think you have gone through so many lectures. So how the rainfall runoff modeling help us to quantify the discharge amount, to know the to quantify the flood amounts. Then now I am going to talk with you about the environmental isotopes. How the environmental isotopes are helpful to know the different component, to estimate the different component of the stream discharge. So that is we can measure the discharge of a stream with isotopes, because you might be knowing that if you suppose if you go in the very in the higher Himalayan regions where the flow is very turbulent, so in that area, if you want to know the discharge of a streams for a, suppose if you, any company want to develop the hydropower project in that higher altitude region, so only way to measure the discharge in such a region is the tracer technique. So in that in those area, other techniques till now not work because the such in the turbulent flow. So this is the so it is just the purpose of the inform to you that we can measure the total discharge and we can separate out the different components by using the tracer techniques. Not only the isotopes, tracer can be the chemical tracer can be the other tracer also, by which we can develop the by which we can know the contribution of different components. So now I am coming to the first two parts I have finished to you. So what is the floods and what are the techniques by which we can know the floods? So why and how the isotopes are helpful to us? So isotopes are known to all of you. So isotope with the same atomic number occupying the same position in the periodic table but having different atomic weight. So so they are called the isotopes of that element. So because of that property, so they have the similar chemical composition but have different physical properties. So that is the important in the case of the isotopes. They have similar chemical composition, chemical properties, but have different physical properties. So just if you take the example of water, because we are discussing about the floods. So if you take the example of water, so water is, you know, the constituents of the hydrogen and oxygen. So what happens? Any H2O, hydrogen is having three isotopes: H1, protium, H2, deuterium, and H3 is the tritium. Similarly, oxygen is also having three isotopes: O16, oxygen O17, and oxygen O18. So because of that, what happens if whatever the molecule forms in your water, so that H2O molecule chemically it will be the same. It will be H2O, but isotopically it can be the isotopes of H1, and oxygen O16. It can be the combination of isotope protium and deuterium, hydrogen 1, hydrogen 2, and oxygen 17. So it can be the combination of hydrogen 1, hydrogen 3, and oxygen O18. So that is the way how what happens, the molecular weight, overall the molecular weight of your H2O gets changed. So that because of change in the molecular weight of H2O, what happens? Molecules with lighter isotopes are more reactive, and their response to the atmospheric temperature is more. They respond very quickly. Even slight change of the temperature, it will impact the evaporation process. And because of that, what will happen? The difference in the physicochemical property appears in the H2O. So now already I have discussed you. So because of there is one term isotopologs. So if you take the molecules of H2O, so if you take the permutation combination of the oxygen and hydrogen, so more than 19 type of water molecule will form. But chemically, this beaker is having same H2O. There is no variation in the chemical variation within the beaker. H2O is the same, but isotopically, the water is not same. It is constituted by the several type of H2O isotopic molecules. That is the isotopologs. So isotopologs is the different, when we make the different permutation combination of the oxygen and hydrogen, so different molecules of isotopes having different atomic weight will form. So what happens? The molecular weight is changing. So accordingly, what will happen? The physicochemical character of your glass, of a glass water present in the within the glass will change. So what will happen when the chemical physicochemical composition क्या होता है? What are the density, temperature, melting point, boiling point, vapor pressure, viscosity? So all these will change for the different molecular weight. So what will happen whenever there will be the evaporation process? Suppose what is happening as hydrological cycle starts from the ocean, and from here the evaporation takes place. So during the evaporation, what will happen? Lighter molecule will escape first from the ocean, and your cloud will be the lighter in comparison to your ocean water. But what will happen when this cloud moves from over there and condensation process starts? So during the condensation process, heavier molecule will fall first because of the gravity, and lighter will remain in this. So what will happen? Your cloud is in continuous process of condensation, and continuously it is the isotopic character of your rainwater is changing from source up to the mountainous region. So what happened? The character of rain changes from continent and to the mountains region, coastal to continental, mid-continent, and then again to the coastal to inland, and inland to the mountainous region. So it is in continuous process of condensation. So there is separation is going on. Heavier isotopes are falling, and lighters are remaining in the cloud, and lighters are remaining. So cloud become lighter, lighter, and lighter. So at last, in the mountainous region, it becomes your snow and glaciers are the lightest in the terms of the isotopic composition. So here because this variation of isotopic signature, oxygen, hydrogen, you can say concentration of that isotopes, that varies from the coastal up to the mountainous region. So what happens? The parental material character is changing, you can say, because the rain is the only source for all type of water, whether it is a river water, lake water, groundwater, snow and ice, whatever type of water we are seeing on the surface of the earth. So they are all, their source is the only one that is the rain. So that partitioning of stable isotopes of element among different coexisting phases is called fractionation. तो इसको हम फ्रैक्शनेशन कहते हैं. That depends upon the mass and temperature. So because of the mass, it will, if it is lighter, it will evaporate first. If it is heavier here, it will fall first on the surface. So what will happen? That help us, isotope hydrologists, to know the source of the groundwater. And just like human DNA fingerprinting, we do the water fingerprinting. And you might be knowing that these isotopes are now the very popular, not only in the case of the hydrological studies, in every part of the science. Isotopes has been used to understand the various complex process on the very precise way. Even I can give you a simple example. Athletes doping test. You know how we identify that athletes have taken any medicine, any inorganic constituents or not. So basically the carbon isotope. We do the testing of the carbon isotope. So by testing the carbon isotopes, one can know whether our body's blood is containing any inorganic source of carbon or organic source of carbon. So if there is inorganic source of carbon, that means we have taken out some different source. The similar way, there are nowadays several adulterations which we cannot identify by the different techniques, by the chemical techniques or other techniques. So for that also the isotopes are used. For case of the honey adulteration, one of the important things that there is mixing of the different type of sugars in the honey, that is very difficult to identify what is the source of that sugar. So then in those cases, isotopes help. And some nowadays in export policy, European countries, they have made it necessary that without isotope testing, you will not purchase the honey from any country. Even in India is exporter for the honey. So that is the way how the isotope applications day by day increasing in different sector. So I have mentioned you oxygen and hydrogen isotopes. Now the question is, because just you have to cooperate to me, because within a 1 hour class it is not possible to go step by step. So I am missing here some steps. So suppose here there is isotopic variation took place from a coastal areas to mountainous areas, in your river water, in your groundwater, in your lake water, in your melt water. So how we will come to know that yes, the isotopic variation is going on? So that for that we measure the isotopic signature of that particular water. So in that case, for the hydrological study, most useful isotopes are oxygen isotope, hydrogen isotopes, for the process, to know the process. But if you want to know the contamination side, then carbon, sulfur, nitrate, so different type of isotopes for different purposes has been used. So in case of, suppose, because we are talking here in terms of the flood, we want to know the catchment processes. So to understand the different process at different level, so for that here I am more emphasizing on the oxygen and hydrogen isotope. So that is the then you have to measure that isotopes. So just like a chemical measurement, we always use a standard. Here also we use the standards. Whatever the measurement we do, that is the we measure here in the ratios, not a accurate concentration, absolute concentration. Because if you see the measurement of the absolute concentration of isotope, it is very difficult. because their concentration, higher isotopes concentration is in the decimal point, and lighter isotopes are 99.99%. So the scientists, they have developed isotope hydrology measures we will measure the ratio, and that ratio will be used to know the variability of the isotopic signature of the water. And generally you will found that we discuss +10 and -10. This is the just like percent, it is the per mil. Per mil means all the results what we are getting, we multiply by the thousands. So we get here the result in the per mil, and delta notation, it is the signature that we are measuring the ratio. So whatever I will discuss the data with you, that will be the in the notation of the delta O18 and delta D or delta H2. So these are the standards. I am not going. Till now I have discussed about the stable isotope. There is another isotope, you know, that is the radioisotopes, and that work as a timer in the hydrological process. So just for example TTM, for example C14. So that provides us to know, that provides the way by which we can know the flow time within the subsurface or even at the surface. How much time takes from at one place to another place to reach the discharge. So either aquifer, or it may be subsurface stream, or it may be the surface stream. So that help us to know the residence time of a particular water, particular type of water, and it has several applications in the hydrology, and different isotopes, radioisotopes are used for the different, and we can date the groundwater up to the million years, and the groundwater has been dated even in million-year-old also. So that is the way. So I'm not going in such detail, all the details. So I'm coming to directly on the hydrograph separation. So in hydrograph separation, just there are two mixing models. You all know about the mixing model in chemistry. It is used. So that is the mass balance model. So what happens? There may be 2 component, 3 component, 4 component, 5 component. So that depends upon the signature available with you. So that from 2 components to different component, you can go up to the separation of the hydrograph. So I'm just taking the example of simplest way 2 component model. So in 2 component model, if the signature of 2 type of water is known, then we can know the ratio of this water in the mixture water. So that we can separate, quantify by using the isotopic composition of these traces. So for 2 components, equations has been developed, and that includes only the signature of your water. So nothing like that. So whatever that QT is your QT is the total runoff. So then QS is the surface runoff, Q0 is the base flow. So if you want to know the surface quantity of the surface runoff, because here we are talking about the flood. So how much surface runoff coming in a river? So then by using this simple equations, we can know the amount of the discharge in a river. And it has several applications, not only in the hydrographs, in the different sites, in different aspects, groundwater, climate. So मैं उसके detail में नहीं जाता हूँ. And then so just I will discuss you one example of the Gangatri Glacier. So you all know about the Gangatri Glacier, so I'm not going in detail because there is limitation of time. So that is the largest, one of the largest glaciers, and which from where river Ganga originates, and that glacier is receding at a faster rate. So then it becomes a duty of the hydrologist, so to know how much contribution we are getting from snow and glacier, because if suppose there is no glacier, what would be the impact on the river Ganga? few people say that no, Ganga will dry up. So what would, without any understanding how we can claim that? So just we started National Institute of Hydrology to understand what is the contribution of the snow and glacier in Ganga River in the headwater region. So and then how its composition changes, contribution of different components changes when River Ganga travel up to the 100 km, 200 km, and even up to 2000 km up to the Calcutta. So how what are the different components which feed to the River Ganga? So just I will show one example of the Gangatri. Here because here one thing thing which I want to show you very interesting. This is the rainfall, and red one is the rainfall of river year 2004, and blue one is the year 2005, and respectively this is the discharge for the 2 years. So that whenever there is if you see the example of river year 2005, so whenever there is the rainfall, discharge suddenly falls in the stream. So that is for hydrogeologists, it is not digestible, because if it happens, so then why the flood will come? So every stream's response to the precipitation. So why here we are getting declining trend of the discharge, not only on one day, in every events, whenever there is a rainfall, your stream discharge declines. So that was discussed with the glaciologists during those time. The study was carried out in year 2006, 4 to 6. So during those time, the concept was that in the high altitude regions, rain has no impact on river discharge. So that is the way why river discharge may be declining. There are no concrete understanding why this process happened. So because during that time we were measuring the isotopic character of the precipitation, isotopic character of the river, and isotopic character of the snow and ice also in accumulative way. So then because all these data we started to measure, and just to because that was the first study for us also to apply the isotope in India, to separate out the hydrograph component. I think if you go in the literature, I think it will be the first study. So that then we decided, okay, let's see how the isotope will help to develop the understanding. So we because as you know, in glacial regions certainly the temperature will play the role. So we also started to develop the relationship of discharge with the temperature. There was good relationship between the discharge and temperature. So then what happens for both the year. So this is the data, how we develop the different, and we get the isotopic variability in different months in the river water. It is not like it was May to June, it was different because it is a pre-monsoon season. During the July to September, during the monsoon, isotopic composition was entirely different. It means this is the season when there was no rainfall, and it was the 100%. It was fed by the snow and glacier. This is the part when the river was fed by the meltwater. Rainfall and up. So this you can see, this is the how the variation is taking place. Isotopic composition of the river water. Whenever there is rainfall, isotopic composition changes and discharge declines on the same day. So that variability provided a ray of hope for us. Yes, we can quantify the amount of the rainfall and up in the river at the snout, in the Bhagirathi river at the snout. So then we accordingly applied. I'm not going much detail in that. So accordingly, we applied the two-component model. So two-component model, we applied the two-component model for single event because it was our first study. So we started with we thought that we will go event wise event. So whatever 3-4 events of major rainfall took place during those times. So we take all the events separately, and we started to measure. So before the rain, isotopic composition of river was minus 13.6. So it was here. But after the rain, its isotopic composition was minus 16.7. So that comes to our knowledge why this isotopic composition changed. So when we see the isotopic composition of the rain, it was the minus 21.9. So it means that component is contributing to your stream flow after the rain. So it means rain is contributing. So using that two component equation, we computed the runoff contribution, and we found around 40% contribution is coming from the rainfall runoff. Even though discharge is not rising, discharge is declining. But river is receiving the rainfall runoff. That now we were clear at that point, and that exercise we did for all the event on the event-wise event scale, and then we went on for the whole season, for whole the ablation period, and we found that rainfall contribution to stream discharge is varying from 23% to 55%. That is another that was a really very important finding, and that during those time, and at that time the glaciologists were not accepting these results. So there within the institute there was a dispute. So the people were talking then if stream flow is that rainfall runoff is received by the joining to the stream flow, then why the discharge is declining? Then for that we did the exercise which I have shown you, relationship of the temperature. So what is happening when there is the cloudy weather? Temperature is declining. So when the temperature is declining, so what is happening? The whole melting process is declining. So whatever contribution we were getting from the melt contribution, that has been declined substantially. So that is the way why that was the reason why we are getting low discharge in the river, even though we are getting rainfall runoff contribution. So then that paper was published in different journals also. And after that, glaciologists who did modeling, they started to make a fraction of the rainfall runoff contribution. Earlier, only people were talking about the snow and glacier melt, 100% snow and glacier melt. So how the isotopes help us to understand the various processes? This is the one example. And overall, whatever the contribution we get, if you see in the totality, we not only we stop our study only up to in the separation of the rainfall runoff contribution, we also went further and we identified the snow and glacier on an individual scale. It was the first study when we started with that how much contribution coming from the snow melt and how much contribution coming from the snow. It means we are getting around 60% contribution of the total discharge is coming from the snow. So that is very important. If snowfall process continue, even the glacier melts, then our rivers will get sufficient amount of discharge from the snow melts. So snow is very important, even I think from the ice. So then after that we that validated with other techniques, and we found the similar results. Then I will quickly show you another example. You might be knowing about the flash flood in the Kedarnath Valley in June 2013. So that was a disastrous flood, and which washed away whole the urbanization around the temple. You might be knowing all these things. But during that time, it was debate from where that amount of water came in a Kedarnath Valley, particularly in Kedarnath Valley. So then several theories came. Some people say that there is the globe. Some people say no, there was a lake and that lake overflows. So there, and somewhere say no, there is only rain fallen up. The amount was controlled by the precipitation. So fortunately, during that time, their one small scale project was going on in that area. So we were having the data. So just we started to look in our data, and we found that there was the rainfall. Blue one is showing the normal rainfall at different stations, and the observed one during that June was it reaches up to around 600 millimeter. So that was the magnitude of the rainfall. A large amount of precipitation took place in a short time of period. Then isotopic composition was because we were in the process to measuring the isotopic signature of the Kedarnath Valley. So data were available. So what we observed, this one is the pre-event rainfall. Pre-event rainfall, the discharge signature was lying between the -11, -12 only. But what happens after the event? Meltwater composition changes up to the -16. So then we thought why it changed. Then we see the isotopic composition of the rain it was around -19. So that rain contributed to this meltwater, this runoff, and the main cause of the disaster was the rainfall runoff. There was it was not. People were suggesting that suddenly snow melt took place and it has caused a disaster, but we found that no, that rainfall runoff driven runoff it was the main cause for the generating the flood in that area. So before the event, snow and glacier melt was dominating in the stream, but after the event, the rainfall runoff dominated in the stream. So that we proved with the remote sensing data and snow cover, because if there is sudden change, sudden melting of the snow and cover, so that should visible on the remote sensing data. But there was no much variation in the extension of the snow and ice. So that was another proven, and then we published that data also. So that is the next example. Now I'm finishing here. Okay. Thank you for patient hearing. Thanks.
Thank you very much, sir. This is Rampal Singh.
Okay, sir.
Hello. Am I audible, sir?
Yes, sir.
I am also one of the coordinator with Professor H.K. Pandey and Pramod Soni.
Oh, yes.
So we have a very nice discussion and informative about the role of isotope techniques in management of flood. Sir, it was a really worth for the participants. You have explained nicely how stable isotope ratio changes, how radioisotopes can be utilized for the flood management, hydrographic separation, 2-component and 3-component mixing models, and take an example of Gangatri Glacier and many more things, sir. It was really very good for us and for the participant to acquire knowledge how isotopes can be used in the management of flood. So once again, I thank you from my heart and from my team side, sir.
Thanks, sir. Thanks for Nice words, and thanks for giving me opportunity to deliver and interact with you and all the participants. So
Yes,
really,
yes.
I'm thankful to you.
Thank you, sir. Thank you very much, sir.
If
Thank
there
you.
is any query from the
Ah,
participant, I can.
yes, participant can take queries from sir. He is available right now. Participants. Hello, am I audible? Hello.
Nobody is responding.
Any question, please? Hello. No question? अरे कुछ पूछिए भाई सर से, इतना बढ़िया आइसोटोपिक application in flood management it was there. You ask?
It has two meaning. Either they have understand all the things, or either they could not understand anything. Okay.
Okay. So if there is no question, we will proceed for the next lecture. And I once again thank you very much, sir. Though
Okay,
we could not meet physically because of online mode. So
okay.
definitely we will meet sometime ahead. Okay, sir. Thank
Okay.
you a lot, sir. Thank you a
Thank
lot.
you.
Okay, sir. Okay, sir.
Okay, sir.
So, PK Singh Dikshit, sir. Sir, are you here? Hello. Hello. हेलो. हाँ नमस्कार सर, आ जाइए. हाँ ज्वाइन कर लीजिए. क्या तबीयत खराब है क्या आपकी? हेलो. 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 दीक्षित साहब से ना. हाँ सर का कंक्लूड कर दिया हमने. हाँ हाँ तो वो जो है सर आ जाए तो फिर बताएं, बोले हम उनका. हाँ ठीक है, ठीक। Participants are requested to please wait 2-3 minutes till next speaker, Professor P.K. Singh Dikshit, joins. Hello. Hello. Sir, am I audible? Sir? Sir, I am audible? आपकी आवाज नहीं आ रही सर। हेलो। क्या हुआ? तुम नहीं लगा? हाँ? So, how it can be done?
Mic is on, sir. Then only speaker will come. Even speaker mic is also off, sir.
नहीं तो ये कैसे आप ऑन हो?
Sir, we are attendees, sir. We cannot do that. Only guests can do that. Sir, can
सोनी को फोन करें?
हाँ, sir.
हेलो। माइक? हाँ, माइक बना है, ठीक है। अच्छा, अलाउ माइक कर दिया। नहीं, प्रभात करके ज्वाइन करे हैं। हाँ, ये तो अरे माइक के जगह ये 3 डॉट हो जा रहा है वहाँ। हाँ, कर दिया, अलाउ माइक भी कर दिया हमने। हाँ, उनके सामने ही किया है। हेलो, हेलो सर, हेलो, हेलो, एम आई ऑडिबल सर? सर, सर, प्रभात सर, हेलो, हेलो। उनकी आवाज नहीं आ रही ना? हाँ, हेलो।
Sir, Prabhat sir is also mic is out, sir.
हाँ,
Prabhat sir mic is out, sir.
कहाँ से देखो?
हाँ.
ये देखो, अलाउ माइक कर दिया
हाँ sir.
तो फिर
Hello mic.
हाँ,
Hello mic पे
हेलो, देखो नहीं हो रहा। ये प्रभात कहाँ चला गया? अरे वो क्या नाम? हेलो, अभी नहीं आया सर। हेलो, हेलो, अब तो नाम ही गायब हो गया।
तो वो फिर से ज्वाइन कर रहा होगा।
हाँ,
फिर he is joining again, I think so.
हेलो, हाँ प्रमोद, अरे कहाँ पे हो? हैं? अरे अरे वो ज्वाइन नहीं कर पा रहे हैं भाई प्रभात जी। हाँ, अच्छा, थोड़ा एक जगह रोक करके इसको कर दो, ज्वाइन करा दो। अच्छा, तो बताओ कैसे कराएं? हम करा रहे हैं, बताइए। हैं? लिंक तो मिला है लेकिन आवाज नहीं आ रही यार। वो कैसे?
हाँ, हो गया हो गया हो गया हो गया हो गया
हेलो,
हो गया,
हाँ प्रभात जी।
हो गया हो गया
हाँ,
हाँ, हो गया भाई, हमारा हो गया।
अच्छा अच्छा, थैंक
हेलो,
यू थैंक यू।
आरपी सिंह
हाँ
साहब,
हाँ हाँ
आवाज
हाँ,
आ रही
मैं
है?
आरपी सिंह मैं बोल रहा हूँ।
आवाज आ रही है? नमस्कार, मेरी आवाज आ रही है?
जी नमस्कार नमस्कार, आ गई है आपकी आवाज।
हाँ, लेकिन
ठीक है,
प्रेजेंटेशन का नहीं आ रहा है। प्रेजेंटेशन कैसे होगा?
प्रेजेंटेशन
हाँ,
प्रेजेंटेशन कैसे?
Presentation.
तो मैं कैसे बोलूंगा?
प्रेजेंटी, एक मिनट, आपका नाम कहाँ, यहाँ आ नहीं रहा है।
प्रभात, प्रभात, आवाज तो आ रही है मेरी? मैं हाथ
हाँ,
रेस किया
आवाज आ
हूँ,
रही है।
हाथ रेस किया हूँ, हाथ हैंड रेस किया हूँ।
अच्छा अच्छा,
Alphabetical basis.
एक मिनट, बस एक मिनट वेट करिए। हाँ है, आपका नाम नहीं दिख रहा है सर।
प्रभात, प्रभात।
हाँ हाँ, पहले आया था लेकिन अब नहीं दिख रहा। हाँ, अब
मैं
आ
दोबारा
गया।
आ
हाँ
गया।
हाँ, अब आ गया। तो हाँ,
Hello camera with this one.
अलाउ, और क्या करना है?
Presenting करना. Presenting.
राइट क्लिक किया, कहाँ पे?
उसके ऊपर
हाँ,
left click. तो शेयर कर सकते हैं सर.
हाँ, दोनों लोग गायब हैं यार, क्या हो? एक मिनट सर, एक मिनट। अरे सर प्रॉब्लम यहाँ आ रही है, वो प्रेजेंटर कैसे बनाए प्रेजेंटर, और स्लाइड नहीं आ रही है।
प्रेजेंटर में सर वही करना पड़ेगा आपको ना, अलाउ वीडियो, तो अपने आप आ जाएगा।
हाँ
अलाउ जो है वो प्रेजेंटर जो है अलाउ वीडियो करेंगे ना, माइक जैसे इनेबल हो गई
हाँ
तो वैसे ही वो भी हो जाएगा।
हाँ
सर करना पड़ेगा आपको, आप अपन दे दिए सर, सर को कैमरा भी दे दिए, माइक भी दे दिए।
हाँ।
सर को अगर सर
ये डिसेबल क्यों कह रहा है?
डिसेबल माइक नहीं करना सर, डिसेबल मतलब माइक तक चले जाएगा।
हाँ
सर करना है, सर कर,
कौन?
सर को बोल दीजिए, सर करेगा, प्रभात सर।
नहीं शेयर नहीं हो रहा है ना स्लाइड।
सर का नहीं हो रहा है।
हाँ
अभी हो जाएगा सर, वो उस टाइम पे।
सर प्रभात सर
जी हाँ, आवाज आ रही है?
आवाज तो आ रही है, ट्राई करिए वो शेयर का।
मैं शेयर वाले में यहाँ पे जो एरो है ना,
हाँ
उस पे ला रहा है तो कह रहा है कि ओनली मीटिंग ऑर्गेनाइजर एंड प्रेजेंटर्स कैन शेयर। हमको अलाउ करिए एज ए प्रेजेंटर।
हाँ एज ए प्रेजेंटर।
जी
एक मिनट वो कैसे करते हैं वो नहीं मालूम है ना। हाँ?
अरे प्रमोद को बोल दीजिए, वो शायद उसका है ना ओनर।
अरे वो गाड़ी में है इसलिए जो है।
पहुंच गया होगा, 5 मिनट में पहुंच जाएगा वो।
हाँ
ओनर है, ओनर वही है ना।
हाँ इसीलिए हमसे तो हम लोगों से नहीं आ रहा है ना ऑप्शन करने का।
कोई बात नहीं, धीरे धीरे हम बोलते चल रहे हैं, बाद में जब होगा तो स्टार्ट कर देंगे।
ए प्रभात जी। हाँ
हेलो
आ गए
सर, नमस्ते। अभी हो रहा है सर प्रेजेंट?
ना हो नहीं रहा ऐसा ना।
अभी देखिए सर।
नहीं
हाँ हाँ
प्रेजेंट अब होगा सर।
हाँ हाँ
हाँ अब हो गए ऑर्गेनाइजर में, अरे उसमें प्रेजेंट। ओके सर। हाँ नाउ योर स्लाइड इज विजिबल।
ओके
ओके सर।
okay okay but I want
So
to share the whiteboard
Sir,
also along with this one.
Let me speak about you one minute. Okay sir.
Okay.
Okay, so this will be the topic na, planning and design of river training works.
Okay जी.
Okay, so I welcome my friend Professor P.K. Dikshit. He is presently head of Civil Engineering Department at IIT BHU Varanasi. He has more than 24 years of teaching experience in his career in the specialization of water resources engineering. He has completed a number of projects in different areas related to water resources. He has more than 60 publications in his credit. He has applied also for a patent. He has guided PhD, MTech, etc., a number of PhD and MTech. He is deeply involved in various consultancy projects of worth more than 10 crores. He has written books and book chapters. Or with this background, I invite Professor P.K. Singh Dikshit for giving a talk on planning and design of river training works. So, sir, I welcome you and invite you for the talk.
So
Okay,
thank
sir.
you everybody for inviting me to present a lecture. Earlier the topic was a little bit different, but what? Hello, am I audible to you?
Yes, yes, you are audible.
Okay. So and my
It was flood estimation for hydraulic structures. Earlier
yeah.
it was.
So what I observed that same topic was delivered by another fellow. So I changed my topic in this one. That is a part of that hydraulic structure which we deal with. Okay. So before discussing, is my slide is visible to you?
Is it in PowerPoint mode? Okay. So before discussing the things, planning and design of river training work. So mostly we do the river training work for protecting the flood of certain stretch. So before discussing the river training work, let us discuss what is flood. So a flood is commonly considered to be an unusual high stage of a river. For a river in its natural state, occurrence of flood usually fills up the stream and its bank and often it spills over to the adjoining floodplain. So what we consider in a stream is something like this, in which this is the normal water level during the course of time. And as discussed, when this river spills over, it forms or spills over the bank. So this stage is known as flood. So the two difference is the normal stream flow and the flood, which is a usual thing. So classification of river training work. So we classify our problem into different conditions. First is flood protection. So in this flood protection, river training for flood protection is also referred as high water training. The aim of this process is to provide a sufficient cross-sectional area for safe passage of flood. It consists of proper location, alignment, and height of embankment for design discharge. The next one is maintaining a safe and good navigable channel. So in this, maintaining a good and navigable channel, sometimes we refer this as low water training. The aim of this training work is to provide sufficient channel depth so that navigation took place even during the lean period when there is very low discharge. Then third one is sediment control. So over the next slide we will discuss more about the sediment control. So this refers to the mean water training. In this, the aim of training is to rectify the river bank configuration and effective movement of suspended and bed load for keeping channel in a good state. The maximum aggregating capacity of stream occurs in the unity of mean water or dominant flood discharge, and therefore changes in the river bed should be attempted in this stage. The next one is stability of channel for prevention of bank erosion. So bank erosion is a common feature during the process of meandering. The river course also keeps changing, and there is a tendency to meander, either to shift progressively down in the downstream or make a cutoff. So later on we will discuss in the next slide what are the purpose and how it took place. The process of meandering and consequent bank erosion continues and it offers a recurring problem. Bank protection is therefore an important part of river training. And the last one, direction of flow in a defined stretch. This is also required to protect some important structures, especially hydraulic structures like barrages, bridges, etc. And for that, the protection work which we make is known as the directing the flow in a particular stretch. So if we discuss the
हेलो
river, hello,
प्रमोद जी, प्रभात जी,
जी सर,
आपकी स्लाइड मूव नहीं कर रही है, इट इज स्टैंड स्टिल.
ओके ओके,
हाँ,
ऐसा?
अब चेंज हुआ. हाँ, अब तो चेंज हुआ.
This was the first slide in which we discuss about the flood protection, maintenance of safe and navigable channel, sediment control, sediment stabilizing channel for prevention of bank erosion and direction of flow in a definite stretch. After that, we divide our channel or river system into three parts, which are classified as zone 1, zone 2 and zone 3. So most of the big river protection work or dam etc. are formed in zone 1, where enough slope is there, and due to this slope, for small if we go for a storage elevation curve, for enough area is available for vertical rise, so most of the big structures are made, means dams are made in this zone 1, and this is the zone where most of the sediments are produced, and even the topography of this area is so steep that even for a small discharge, huge amount of silt and sediment transport took place. Then second is the zone 2, in which most of the sediment is transferred, and third one is the sediment deposition or toward the delta side, where sediment is deposited. So the river training work is mostly done in zone 2, where the slope is limited or flat slope is available over here, discharge is here, river bank is such that flooding took place and lot of destruction took place, so we are mainly concentrated over here. So if we talk about river is a living system or is zone in which if we change any part of the river system, the subsequent changes took place in the entire system. And in 1972, H.A. Einstein stated this fundamental concept that a stream is a part of large complex system, and if we change a river, we usually do some good somewhere, and good in quotation mark. That means we achieve some kind of a result that we are aiming at, but sometimes forget that the same change which are introduced may have widespread influence somewhere else. I think if out of today's emphasis of environment, anything result for us, it is that is emphasize the fact that we must look at the river or a drainage basin or whatever we are talking about as a unit with many facts. We should not concentrate only at the little piece of that river unless we have some good reasons to decide that we can do that. What is the aim? Plenty of theories are there, and all theories define that for a given cross section, slope, discharge, a particular silt carrying capacity of channel in a channel, particular silt carrying capacity exists. And if we vary any of the parameter like discharge or slope or any parameter, the silt carrying capacity decreases, and that is the result that if we change profile of any river anywhere, the changes is triggered not only in downward direction but upward direction, and aggradation, degradation, or all type of phenomena took place. For example, if we build any small reservoir, a dam, or anything at any location of the river system, siltation in the upstream and erosion in the downstream start taking place, because in upstream discharge velocity decreases, so sediment starts getting deposited, and in downstream, due to lack of sedimentation, erosion starts taking place. So building of slope and flattening of slope took place. In this diagram, if you see, during the lean period, the thalweg or central line of low flow is like this, and if we see the profile of thalweg point, it decreases as well as increases. The depth of water increases or decreases along the profile. So this change in the curvature is only because of one reason, that for a given elevation difference between this point to this point, river tries to build a slope, a particular amount of slope, and for that it does the meandering, either is shift towards any side for increasing the slope, or is straighten itself to decrease the slope. That is a river is there, and in between these 2 points, if this is the elevation difference, by flattening its length, it is decreasing the path. It means length is reduced, so slope is increased, and when length is increased, it means this length is increased, so flattening of the slope is taking place because of this increase in the length. So that is the tendency of a river to make itself in a dynamic state by changing her course, by increasing the depth or decreasing the depth. For same elevation difference, by changing her path so that it may increase or decrease her path. So under the low flow condition, if we can see, this is the thalweg or central line of the flow which is taking place, and when river is under flood, this is the maximum flow, and mostly the path is nearly in a straight line, not in this curvilinear path. So this is the profile of the section under the lean flow, that is thalweg profile. So type of river training work. So first is levees or embankment. So levees or dikes may be defined as an earthen embankment existing generally parallel to the river channel and designed to protect the area behind it from overflow of flood water. The embankment are the oldest known form of flood protection work, and extensively used for this purpose. Then we classify this embankment or levees into three categories, that is low embankment when height is less than 3 meter, medium embankment when height is in between 3 to 9 meter, and major embankment when height is greater than 9 meter or max more than 30 meter. So for this, the design flood for fixing the crest level, we take the design flood as of the embankment, this type of embankment as 25 years for fixation of crest level. Then design of flood for embankment, if they are adjoining to a township or industrial area, then for such type of embankment, we keep the design period, flood design period as 100 years for fixation of crest level. Then alignment, spacing and length of these embankments. So depending on the lessee wetted periphery, which is P is equal to 4.75 2 to the power half, we normally keep our spacing of embankment along with jetted to the river not less than 3 times of that lessee's wetted periphery, and the minimum distance of the embankment from river bank and midstream of the river should not be 1 to 1.5 times the lessee's wetted periphery. The length of embankment. The length of embankment directly depends on the alignment. How and which type of alignment is there? Sometimes we make alignment embankment on one side, or sometimes on the either side of the bank of the river. And for the design of this embankment, IS code 12094 2000 is mostly effectively used. So after that, we divide our embankment into three categories. That is, first, homogeneous embankment, in which the which is the simplest form of earthen embankment, in which only
Sir, sir, I think slides are not moving, sir.
yeah, I am discussing only the first one, levee or embankment.
So you are on the slide number 5 actually.
Yeah, 5 of 5, the first one, levees or embankment.
Okay, so you are on the slide number 5 only, right?
Yes, yes.
ठीक sir.
So three type of embankments are there for, as per the name: homogeneous embankment, then zoned embankment, and diaphragm type of embankment. So these are the three types, and as per the name, in zoned inner, there is an inner core, and diaphragm there is a center diaphragm type of embankment. The next one is freeboard. So for design of levees or embankment, what we do, we take the freeboard based on the fetch length, that is, what is the length of the wave which comes. So SW, it depends on the fetch length, whether it is greater than 32 or less than 32 kilometer. And our freeboard for wave action is 1.5 times of this wave height. So actually, I was thinking that I can take both presentation as well as this slide. I'm unable to see my whiteboard. Earlier I was drawing the things on the whiteboard. Now I am unable to see this whiteboard.
Sir, do you see the share option in the share tray? Is it not available in the share
No,
tray?
in Windows I am unable to see. Anyway, I am directly coming to the presentation and I will dictate the
So
formula.
maybe you can use the pen there in the PPT itself. You can choose the pen.
Pen.
You right click on PPT and there will be an option for pen.
Okay. Okay, it will be good for me. Thank you.
Welcome.
So SW, which is in meter, is equal to 0.032 into VF to power half plus 0.763 minus 0.271 F to power 1 by 4.
Sir, I think the slide is different. Are you on slide number 6? Types of river-turning works, levees or embankment?
Yeah, anywhere I'm writing in the things.
So it's not coming on the screen actually. The write-up. Maybe you can minimize and maximize. I want to see. So
No, type of river.
type of river-turning works, levees and embankment. You are on the slide.
Okay.
But
So
the
here
write-up
I
that
can
you're
write.
writing. You can write sir here also.
Okay. So HW, and normally the freeboard is 3 times of this one. Sorry, 1.5 times of SW, where SW is equal to 0.32 into VF to power half plus 0.763 minus 0.271 F to power 1 by 4, where F is phase length and less than 32 kilometer. F is less than 32 kilometer. For this is the formula, and H is in meter, and when it is greater than 32, it is 0.032 VF to power half for F greater than 32. In this, V is the velocity in kilometer per hour, and F is the length or phase distance, the maximum length in kilometers. And our wave action is 1.5 times of this SW. So this is the normal formula, but sometimes in absence of the data, we keep freeboard as 1.5 times, and for discharge less than 3000 cumac, and 1.8 for this discharge less than greater than 3000 cumac. So the freeboard 1.5 and 1.8 are kept for the reason that when we are having less reliable data or short duration of hydrological data, so in order to carry the uncertainty, we are keeping 1.5 and 1.8 respectively freeboard for the different land. But if our data is reliable, enough and sufficient data for more than 35 years is available, then we can keep these as 1 and 1.5 or lesser value 1 to 1.5 depending on the situation and criteria. Now top width of our levee so for top width, generally we provide this so that enough space is available for the movement of vehicular traffic. So normally it is kept as 5 meter. Top width is kept as 5 meter, and a turning platform of 15 to 30 meter may be provided at an interval of 1 kilometer or more, then hydraulic gradient. Our aim is to keep the embankment such that the hydraulic gradient must have sufficient cover of 0.6 meter. So for that, for clay soil, we normally provide 4 horizontal is to 1 vertical, clay 5H is to 1 vertical, and sandy 6H is to 1. So these are the, as time is running out, so I am trying to cover other things. So river side slope is also there, and normally river side slope is flatter than the countryside slope. So depending on the height, up to 4.5 meter, 2:1 is provided, 2 horizontals to 1 vertical is provided up to a height of 4.5 meter, and for other 3 greater than this, 3 horizontal is to 1 is provided. Then borrow pit. So as per IS 11532, borrow pits should be preferred to the river side and located at least at a minimum distance of 25 meter from the toe of embankment. And in order to obviate the development of flow parallel of embankment cross bars, width of 8 times to the depth of borrow pits at rate of 50 to 60 centimeter shall be let in the borrow pits. Then drainage and cause of failure of this embankment. So the cause of failure of this type of embankments are the improper compacting and settlement of embankment, then traverse cracks due to unequal settlement, inadequate drainage and poor pressure development, erosion and riverside development due to river current and wave wash. Now, the bank protection and pitching of bank.
Hello. So is there any issue with PPT, sir? Is it okay?
No, actually it was, I was trying to erase the thing, so no. Band protection and pitching. So as per IS 14262 1955, the pitching of requirement is there. The weight of a stone on the slopes in kg W is equal to 0.02323 into SS into V to power 6 divided by K into SS minus 1 Q, where K is correction factor of slope, which is equal to 1 minus sine square theta upon sine square phi to power half, where SS is the specific gravity of a stone, theta is angle of sloping bank, and phi is the response of material of protection work, angle of response of material of protection work, and v is the velocity in meter per second at the bank. So for this pitching natural bank, and angle of response and cohesion of bank material is there. Then size of boulders and stones. So size of a stone ds is equal to 0.124 into W by SS to power 1 by 3, where W is weight of stone and SS is specific gravity of the stone. Then thickness of pitching T is equal to V square by 2G SS minus 2, where SS is specific gravity. Similarly, the pitching in crates are done, and porosity of those crates can be worked with the different formula. Then we provide filters and do the paneling, then top key and bonds are provided. Then pitching of mortar and other things are there. Then let us come to the groins or spurs. So this type of protection comes under anti-erosion work. So groins are the structures constructed traverse to the river flow and extended from bank into the river. These type of works are provided to keep away the flow from erosion prone bank. So depending on the type, 3 types are broadly it is divided into repelling and attracting groins. Plenty of classifications are there of these groins, but we are sticking to repelling and attracting. So function of these groins. So function of these groins are many. So few among them are to train the river along the desired course to reduce the concentration of flow at a point of attack. Then protecting the bank to keep the flow away from it, creating a slack flow with the object of splitting up the area in the vicinity of river bank and improving the depth of the river for navigation purpose. Then classification of groins which we have discussed. So IS 8408 1994 deals with the orientation of groins and spurs. So for this, the design discharge for groins and spurs are normally taken as the design period of 50 years flood, 50 years. Then length of groins. So length of groins are decided based on the anticipated maximum scour depth ds, and we keep the length of this groin as equal to 2.5 times ds. Later on we will discuss what is this scour depth. So normally effective length of these groins are not exceed the 1/5 of the width of the flow in case of a single channel. In case of wide or braided channel, sometimes it may exceed, but normally it doesn't exceed the 1.5 times the width of channel on which groin is proposed, excluding the length over the bank. And spacing of these groins are kept as 2 to 2.5 times the effective length. Then top width of groins and freeboard. So the top width of groins are kept as 3 to 6 meter as per requirement. 3 to 6 meter, depending on the requirement, and a freeboard of 1 to 1.5 meter is provided above the design flood level. Side slopes are provided as toward the side and nose as 2:1 and 3:1. Then next one is guide bank system. So as discussed earlier, guide bank system is constructed in the direction of flow both upstream and downstream of the structure on any or both flanks as required. So these guide banks are classified according to their banking plane and their geometry in shape. So guide banks of course diagram is not very much clear, but here x square by a square plus y square by b square is equal to 1 is there for. So this is an elliptical shape of guide bank in which this is 0.25 to 0.4 meter length. This is A, this is B. Angle is 30 degree to 45 degree. Radius is 0.5 r to 0.25 L. Similarly, R is equal to 2.25 L. Same shape is there, 45 to 60 degree. So the general practice is to keep the upstream length of guide.
Hello, sir. I think, sir, can you change it to the normal mode? I think in the slideshow mode, the equations are not visible. Can you change to normal mode if you're in the slideshow mode? So we are not able to see what you're writing on the screen. Probably because of yeah, no, not that visible, sir. The guide bank system is visible. What you're writing on the screen was not visible.
No, is it visible?
Sir, the slides is visible, but whatever you're writing, it is not visible now.
Okay, at that time, the thing which I was writing was not visible.
Sir, sometime it was coming and then it went away, I think. Maybe you can try to reshare the screen, sir. Maybe it's a problem with PPT. If you just share your entire screen, this may be visible.
So I'm sharing right now. Of course, this one
yes,
is
sir,
not visible. This one is more blurred.
So it's not about blurring, sir. It's actually some part of the PPT may not be visible when you share the presentation. Instead, if you try to share the entire screen, everything will be visible on the screen. So for once, maybe you can unshare the PPT and share the entire screen, so we may be able to see that.
So right now I'm writing something. Is it visible to you?
No, not now, sir. No, it was once it was visible, then it went away, I think.
A, I've written A.
No, sir, not visible on the screen. No.
For that,
This is some issue with the PowerPoint. Actually, we have faced many times when we go to slideshow mode. It happens this actually in PowerPoint mode. So that's why some of the speakers they prefer the PDF mode many times.
What I have planned to write the thing on whiteboard, and whiteboard is not coming. Earlier,
right,
but
sir.
Right now it is not coming.
So can you share the entire screen if possible? In that way, we'll be able to see everything you're writing on the screen. If
how?
possible, when you go to share screen, open share tray.
Okay.
In the share,
same thing
you
I'm
see.
doing.
Sir, but you are sharing a particular window. Instead of that, you can select entire screen.
Okay. Okay. I'll touch that. Is it coming?
Something is coming. Yes, sir. Now everything is visible. You can open the PPT.
Is it coming to you?
Yeah, now PPT is visible.
Okay.
Yes, sir. Now you try to slide show it, sir.
Is it visible now?
Yes, PPT is visible, sir. Now. Yes, sir. Now using a pen.
So the length of guide banks. No, but it is not.
Yeah, now we can see what you're writing, sir. Yes. Now we can see it.
Okay. So the general practice is to keep the upstream length of guide bank as 1L to 1.5L, where L is the length of the structure between the abutment. For elliptical guide bank, the upstream length is generally kept as 1 to 1.25L. And for downstream length, the length is kept between 0.2L to 0.4L. Radius of curvature of head and tail are as shown over here: 45 to 60 degree, 30 to 45 degree. This one is 0.25 to 0.4L. This is 0.5 R to 0.25L. This is waterway length L. This length is 0.3 to 0.5 R. Similarly, 40 to 60 degree. Equation of this is x square plus a square plus y square, and this is the river flow direction. So these are the few features for design of these guide banks. Then what are the materials which are used? So normally guide banks are made of locally available material from the river bank, preferably silt, sand and sand cum gravel. The top width of this guide bank is kept as 6 to 9 meter to permit transportation of material. At nose of guide bank, the width may be increased suitably to enable the vehicle to turn and for nosing nose. Again, freeboard is kept as 1 to 2 meter above the design flood level. Side slopes are provided as 2:1 to 3:1. Then for two protection, launching aprons are provided to protect the two and should be form a continuous flexible cover over the slope of scour hole in continuation with the pitching up to the deepest scour. So launching apron should be laid at a normal water level or at a low level, and as soon as this means that low level or means technically feasible there. So this is the launching apron which is laid. The size and of the apron depends on the size of the stone, thickness of launching apron, and depth of the scour, and slope of the launching apron. Now, so I think length of guidement has been covered. So next part is the river training work without embankment. So especially in Burma, a special technique has been evolved on passage streams. So over there, over a Sitang river, they have done this practice. The catchment area of the river was approximately 40 to 400 square miles, and discharge varies between 200 to 400 cusac per square mile of catchment area. So what they have done, they put the river training work over the reclaimed So what was the problem that these streams changes with very speed and cause damage to the communication. So the object was to reclaim the area for paddy cultivation and improve the stream for transportation of log and facilitate their passage. So what they do, they did the depression in aligned and demarcated way by making the fencing of bamboos of depth 1.5 to 1.8 meter with a spacing of 25.4 centimeter apart. 1.5 meter to 1.8 meter logs are placed at a distance of 25.4 centimeter apart, and they are driven to a parallel to a selected concrete of 25.4 meter apart, parallel to the central line on a predetermined space. The fence is secured in lacing the horizontal bamboos for a 15 centimeter below the top. Top. And if condition arises more than two parallel, parallel blocks are placed to make the fence strong. And with help of that, what they observed that during the flood, these fences took the extreme velocity and heavy sedimentation occurs along with these fences. So with help of this, what happens? These fences are there, so scouring over this region took place. So it means a deep channel is formed during the flood, and with help of that, a clear-cut navigation system was formed. So that was the technique adopted in the Burma without making embankment over the area with help of bamboos. हाँ कुछ कह रहे थे?
हाँ पीके सिंह सर थोड़ा वाइंड किया जाए. हेलो.
हाँ हाँ
थोड़ा जल्दी कर लीजिए. हाँ
जी. So these are the few methods by which we can go for the river training work, especially for the regions of zone 2. Is it visible?
Yes, sir. Visible. It's visible.
So this zone 2, in this zone 2, we can do the river training work by or protection of this zone by means of these small structures, and sometimes without any heavy construction like the work done by the Burmans, that making the bamboo locks inside along with the channel in order to make it deepen. In our inland waterways also, in order to provide the minimum depth of 2.5 meter in Indo-Gangetic plain, means from Haldia to Varanasi or Allahabad, same type of technique is adopted, that is bushes are planted along with the river flow so that the river flow confines during the lean period to a particular stretch and a depth of 2.5 meter is achieved over those zones. So these are the few techniques which are used for making the river training work in order to provide a minimum flow or to protect the area, a minimum flow depth during the lean period for navigation and such type of purpose. Thank you.
Okay, any question from participant side? Hello? Any question from participant side? No question? Okay, sir.
Sorry,
Then,
sir, due to illness, I was unable to attend other lecture of other people. That was my misfortune. That I was unable to attend the lecture of other eminent speakers.
okay, okay. So let us conclude this. I extend my warm thanks to Professor P.K. Dixit sir. He has given a nice presentation on river training works and what kind of various structures are used, about them in detail. So thank you very much, sir. Hello.
Thank you, thank you.
Thank you.
And
Thank
today
you, sir.
I'm to learn that on this one. PowerPoint we can write directly. I was not aware of that. Thanks.
Okay.
Understood me.
Thank you, sir. Thank you. Thank you. Because
Thank you
we
so
have
much, sir.
to-
Thank you so much.
चलो ये प्रमोद
हाँ,
you
sir.
inform student within 2-3 minutes we will start valedictory function. Okay.
Sir, we have sent them message. They will be joining soon. Others will also join, and I think chief guest has also arrived. Professor Chandan Ghosh.
Yes,
We can
yes, yes.
welcome him.
So
I think we can request Professor P.K. Singh Dixit. I think he has left. I think otherwise, if he is there, he can also enjoy the
Dixit sir is
valedictory
here.
function.
No,
And
I'm here.
sir.
I'm
He
So
is
please,
here.
sir, it is our request. It is
He
our
is
request
here,
that you
sir.
please be with
Who,
us.
sir?
And, yeah, sir. And Dr. S.P. Raj, sir. Dr. S.P. Raj, sir, if he is there and if he is listening my voice, I also request that he should also join for half an hour. It will be your valuable time I will take on behalf of organizing committee. So I request on behalf of organizing committee to both the guest as a speaker, Professor P.K. Singh Dixit sir, as well as Dr. S.P. Raj sir. So if you are not having any much more busy schedule, please be with us so that very soon we are going to start the valedictory function.
ओके पांडे जी, थैंक यू, बट मैं थोड़ा सा कहीं कुछ काम है, जाना है, कुछ मीटिंग है
सर तो थैंक यू सर, थैंक यू।
ओके सर, नो प्रॉब्लम।
तो फिर मैं थैंक यू आप लोगों को, बहुत बहुत धन्यवाद।
थैंक यू राय साहब, थैंक यू
सो मच सर।
मैं एक रिक्वेस्ट आप लोगों से करना चाहता हूँ। रिक्वेस्ट ये है हमारी कि फ्यूचर में थोड़ा सा हमें टाइम ज्यादा दें आप, क्योंकि एक ही लेक्चर में हमें आइसोटोप समझाना है, मेजरमेंट समझाना है, एप्लीकेशन समझाना है, बड़ा डिफिकल्ट हो जाता है हमारे लिए। थोड़ा सा हमें स्पेस दें, या तो लेक्चर बड़ा कर दें या तो 2 कर दें, तो हम थोड़ा कंफर्टेबली पार्टिसिपेंट्स के लिए भी इजी होगा समझना।
बिल्कुल
सर, बिल्कुल।
तो ये हमारे,
माइंड।
हाँ ठीक है, थैंक यू सर, थैंक
यू सर।
We agree sir, we agree with your suggestion. We agree.
Dikshit sir, sir, you can unshare your screen. I think it's still visible, so you can unshare that. Yes.
Yeah.
अच्छा, हट गया?
No sir, still on the screen, I think. हाँ, अभी हट गया सर। Now it's gone sir. Yes sir.
अब आ गया व्हाइट बोर्ड, अब तक गायब था।
हेलो।
Dr. Pramod, I think we can start now.
We can start.
Yes sir, we can start. So I have shared a PPT for the validity function. So आप शुरू करेंगे सर? आरपी सिंह सर, शुरू करते हैं सर।
यस लड़के आ गए सब लोग?
हाँ, काफी आ गए हैं सर, बाकी ज्वाइन कर रहे हैं। यू कैन स्टार्ट।
ओके, तो कॉल करिए, फिर हम शुरू करते हैं, ठीक है? एज पर शेड्यूल।
हाँ, शेड्यूल के हिसाब से ठीक है सर। हम
ओके, डियर पार्टिसिपेंट्स, my distinguished speakers and the NIDM, MNIT and other those who are present, I welcome all of them in this final valedictory session of the short-term 5-day short-term course on droughts and flood analysis and their management. I welcome today's chief guest, Professor Chandan Ghosh sir, who is an expert. He has also delivered a lecture on floods, and I welcome from my heart. He has kindly accepted our invitation to act as a chief guest for this function. I welcome you, sir. I welcome Professor S.P. Rai, Professor P.K. Dixit, sir, those who have conducted today's schedule of lectures. And I also welcome all the students, those who have been working behind the scene for the last 5 days and even more during entire preparation of this course. So thank you all for in this valedictory function of 5 days short-term course, TAM 2022. More, thank you very much. Okay.
Thank you, sir.
Over to Pramod.
With the very good afternoon. So I'll now request. So first thing is like a briefing of this course. So for the last 5 days, it has been really hectic for all the coordinators and the student coordinators. So I will request Dr. H.K. Pandey sir to summarize whatever we have covered in these last 5 days and brief all the participants about what they have learned. And so thank you. I'll request you to brief the participants about the course.
Okay, thank you, Dr. Pramod. Very good afternoon to everybody who are present at this platform, and they are witness for this valedictory function of this 5 days short-term course on drought and flood analysis and management. Before respected Professor Chandan Ghosh, is from National Institute of Disasters Management, New Delhi, and he is our chief guest of this function. Respected Professor P.K. Singh Dikshit sir from Department of Civil Engineering, IIT VHU, Professor R.P. Singh from Department of Civil Engineering, MNIT Allahabad, Dr. Pramod Soni, and all the participants who are witnessing and have attended this 5 days training program. As I have been asked to some brief about the entire conduct, or you can say the entire completion of the online course, let me very briefly, you can say the narrate whatever has happened or whatever has been conducted in this 5 days course. It is very beautifully planned course within a very short notice of time. And I can say within a 1 fortnight, we had planned this course in the online mode, and we have structured or framed the course in such a way that 13 hours have been allocated for theory, means for lecture, and 12 hours for hands-on session in the practical mode. I am happy to share that the fact that in spite only one lecture scheduled by Professor Surya Prakash, which was in exigency, was not taken by, but it was managed by Dr. Pramod Soni, one of the coordinator of this course, very beautifully. But none of the lecture or hands-on was left over, and participants were never given on hold, or they were not on hold for the sake of just gap, or you can say the vacancy of any speaker or any resource person. So 13 hours under the lecture in the 5 days training program, and 12 hours were allocated for hands-on training in the different software and application of rather these softwares like MATLAB, ArcGIS, then HECRAS, and you can say one another software that is SWOT. So all these softwares were demonstrated with hands-on, and really I am very much thankful to the experts or the resource persons who spared their 3 hours time, and they were always in constant touch and in the online mode with the participants. And whatever the query were raised by the participants were replied then and there. Number 2, all these programs or the lectures and hands-ons have been shown on the YouTube by the NIDM with the courtesy of NIDM, National Institute of Disasters Management. It is also running till date. It is running, and participants and other peoples are enjoying with the YouTube either of the theory lectures, or you can say the tutorials or hands-on session. The third is that more than 133 participants have registered in this course, and they have also got benefit. I firmly believe that they have got the benefits out of these deliberations from the different resource persons as well as the practical session. The resource persons were also invited across the country. It is not just, if you have seen the title of this 5 days short-term course, Drought and Flood Analysis and Their Management. The lectures were on the analysis as well as the management side both. No part has been left. Means you also know that within 5 days everything cannot be covered. There are certain limitation of the online mode also. Sometimes in certain lecture or theory, practical, certain network issues were there, and with that we have ultimately reached or arrived to the satisfactory level of this completion of this course. It was very nicely delivered, or you can say the deliberated on the different issues, drought and flood analysis, right from the applications of you can say starting from the introductory part to the different types of the applications of software, as I have mentioned. And regarding the participants also, as I mentioned, that resource persons were invited across the country from the different corners or different parts of the country to share their views with us, as well as similarly, participants also have been registered from across the country. It means from southern India, from eastern and western India, and central India and northern India, if you distribute like that. And from the student side, then faculty, as well as some certain, you can say the professionals, they had joined this course, and I believe that they have enjoyed this course. So I have tried to summarize in brief about all the proceedings, whatever have been completed in these 5 days online course. Although whatever something if had been left, participants may submit their facts and figures in the feedback session we have kept already for the participants. I would like to inform one important, you can say the notice, that you have to get or download the certificate from the NIDM sites, and from tomorrow or day after tomorrow it will be active. And if you have registered on the NIDM site, you have login ID, and directly you can download your certificate after 1 or 2 days. It will be also intimated in the WhatsApp group as well as through the mail also. So be comfortable, don't get any panic, and I believe that wherever you have or you are, you have enjoyed this course, and certainly we will have in future such opportunity to interact with you. So with these words, I again sincerely convey my thanks to all the distinguished guests who are here, resource persons, as well as all the participants who have in this vacation also, they have spared their valuable time and they have joined and enjoyed this course. Thank you very much.
Thank you so much, Pandey sir. It was really, in brief, you have summarized, and I'll say not brief, it was a detailed description of whatever was covered in these 5 days. We're thankful to you, sir. Now it's time to call our chief guest of the session, Professor Chandan Ghosh, sir. So I'll just briefly introduce the participants about him. So Professor Chandan Ghosh, sir, he is a civil engineering graduate of Bengal Engineering College, so now it's known as the IIST. He did a master's in civil engineering from Jadavpur University, and PhD he got from IIT Kanpur in 1992. And further, he also got a doctorate in engineering from Ibaraki University in Japan. He has been serving NIDM since July 2006 as professor and head Resilient Infrastructure Division. He also served as a faculty of civil engineering at IIT BHU for the period 1990 to 2000 and did his postdoctoral research in Japan. Further, he was on deputation to IIT Jammu from September 2019 to December 2020, where he served as Dean of Student Welfare. So works in the areas of earthquake geotechnology, reinforced earth, seismic microzonation, ground improvement techniques, geosynthetics, bioengineering measures for sustainable development. He has devoted more than 30 years of his career in UG and PG teaching, research, guidance, development of teaching tools, and training module for engineers, architects, town planners. Having published more than 135 papers in reputed journals, conference proceedings, as recognition to his seminal contribution, He received Leonard Prize for the best doctoral thesis in 1993, CIDC Vishwakarma Award in 2013, IGS Sri H.C. Verma Golden Jubilee Award in 2013, and for the Lifetime Achievement Award from Indian Geotechnical Society Delhi chapter in 2019. So without further delay, I'll call our chief guest, honorable chief guest of this session, Professor Chandan Ghosh, sir. Sir, please, you can. I would like you to address to the participants, sir. Sir.
Okay. Thank you. Really, you have Pandey Sahab, RP Singh Sahab, Pramod Sani, and PK Mehta ji, and also with the auspices of your directors on the first day, and the way that you have been running this program. It is all salute to you for keeping us, keeping all the participants active, despite so many things are happening around the world. So you have shown that through such kind of program, even online, taking advantage of what has that brought us not only theory but also practical, which you have taken up, that especially from in the second half with all the 3-4 softwares that which are very much known and available, and where students and engineers, they have got a feeling for the hands-on training that even online, and I could follow some of the lectures that where I see that it is a virtual classroom, but all the experts that taken selected by meticulously by you, they have been they have not lost in the last 2 years of that gap that given us the challenge, the entire world also. So I could see that the meticulous conventionality, pedagogy of teaching and hands-on training, and the lectures that which are taken from the textbook to engineering application and design has made really this occasion, especially for 5 days, really fantastic and enjoyable. And I have no words just to thank you, but the kind of ambience that you have created for the audience, especially those who cannot be seen in this, but at least their presence indicates that they are, even in YouTube also, that they have been very much active. And when you have arranged one lecture 2 days before, I thought that it was 1.5 hours. So anyway, I would like to show a few of the slides, if you can allow me, that one video, and followed by some of the things as a take-up from this session. Shall I share?
Yes, sir. Please, sir.
Okay. It may take 5 to 7 minutes. It is okay?
Of course, sir. Please.
Okay. Okay. Desktop. And then ये screen दिख रहा है?
Yes, sir.
Yes, sir.
Visible. Yes, sir.
Okay. Now it is fine?
Very good, sir.
Okay. So my thing is how to live with flood or how to live with the drought. So I have got only few of the things that are available. You see that Rain Viewer 2.1 version also has come, available in iPhone, iPad, Apple Watch, even Apple Watch, Android devices. You see they have been making, but hardly anyone in the country, even though we have been doing, we are having several, almost more than 100 NBs. Environmental the centers are there. There are so many GIS labs are there, web GIS are there, and we have been practicing a lot of our software. But look at that, when a mobile app is available, more than 100 countries, that this rain viewer, it is a more than 100 countries and more than 1,200 radar data. They are being collated. And look at the kind of coordination that they have to do using the information that available over the net. And then finally, it is that what they are giving, you can see it is a new year, point is here. It is showing that heavy rain 23 minutes from home starts at 10:04 a.m., lasts for 33 minutes. So as a common man or whoever we are, what we expect from our academic research and so many nodal institutions in the country, the information have to be packaged the way that these people have done. They have to be packaged for the common public in such a way that it gives us such kind of realistic information. And I have taken the screenshot. I have not made it, but my appeal is, let us work in this area. We have got several thousands of rainfall, rain gauge, and across the country, more than 2,000 are having even Karnataka, which faces drought. Hardly 200 kilometers south of that, South Karnataka, it is having a rain surplus area where 99% of the water goes to meet the Arabian Sea, and 200 kilometers northward when you come, there our farmers, they are dying, they are taking their life because of the drought. So these are every day, every year, every season phenomena. And this should not appeal us just like that it is a newspaper information. Whether we are living in north part or south part, or whether in the same state or in other state, we have to see that 200 kilometer distant places where canal takes a lot of time. But I have shown in the last part that there are some pipeline in Andhra Pradesh, Polavaram Dam to Krishna. They have made 174 kilometer. Canal is there, rest of the part, more than 174 kilometer, they have made through a heavy duty pump and pipeline under the soil without disturbing any of the flora, fauna, economy, or whatever environment and other things. So when 200 kilometer of pipeline with a 1 meter diameter or 1.5 meter diameter with a flexible geosynthetics or geomembrane, we have got the capacity of laying this pipeline less than 1 day. We have got that. It doesn't take even a day to lay 200 kilometer pipeline. We have got that kind of material as well as construction agency in the country. So then why to go for some of the techniques and other things that, yeah, let us learn this, learn that, when we have got the material. We have got surplus water going towards the sea, and we have got, again, people are dying. And when canal making becomes a lot of problem, pipeline laying of 1 meter, 1.5 meter, even 2 meter diameter, it doesn't. So the kind of information that which we have to collate, where these people, they are able to collate the information of more than 1200 or something at Doppler radar. In our country, we are counting maybe 17 or 20 is there. We are simply counting that another 20 we should place. Even if in the current situation, another 500 also we are placing, we are not going to solve the problem until and unless we bring our software and other things in this manner, customize them to our mobile phone, bring it and show them that at least in what are the direction, what is the rainfall intensity, how it is moving. That kind of sophistication we have to bring in, and we have several our software, and this doesn't need any kind of science or any kind of other things. This is one thing. Then second thing is, I would like to say that how plan your day. We can plan our day. We can bring it, and where precipitation is happening and what are the map is. It is all interpretation of the data that which is available online. Similarly, what far from my home that precipitation or rainfall is there, these are being made available. Now, by since it is available, only thing is that it will not give anything exact in Prayagraj or in Delhi until and unless we connect all the rain gauge related information into the software. Similarly, whatever is the rainfall estimate that we give, rainfall measured accurately, not by ground station, which often goes out of order or not properly maintained. You can imagine when cyclone is moving at a speed of 200 kilometer, and we are keeping our rain gauge like this, 6-inch or something rain gauge vertically, and then what kind of authentication of the rain that you can expect from those rain gauge which are showing vertically and rain is moving with the speed horizontally. So we have lot of such weather model to calculate the approximate rain. But how much rain that we are able to calculate, more important is to distribute them to make all these calculations show in our Google map or whatever it is, the intensity of rainfall, rather than for entire city that we say that there may be some rain, smaller rain, some may not be there. That kind of information, we can customize them more particularly in the map, superpose them, so that it becomes a very, very meaningful depiction of the rain intensity that where it is. Not only this, after this, we have to go for that in our local area, colony, or in the bazaar, or even in the wherever we say, we have to customize our rainfall data, say that, and also not that 1:10,000 scale or 1:5,000 or 50,000 scale that we dream a lot with that. But we have to bring in 1:1 scale, which is being done using LiDAR camera, that 1:1 or 1:10. Then only we will be able to say that in our locality, like this is, for example, being shown over here, in my locality, if it is raining, when we have got the contour of my area, and if it is raining for 15 minutes in my area, where is the inundation? What kind of measures to be taken? Simulation. Let it. I will show one such thing, that how simulation is being done practically, which is as realistic as it is. So we are more interested to know that if it is raining for 15 minutes or 1 hour or 2 hours in my area, what will be the inundation depth in my area? So our software, GIS, web GIS, and whatever things that hands-on training has been done, we have to come into this level. And for this to get the contour mapping, it is a matter of like Delhi-like area, 1600 square kilometer area. Contour mapping of 1600 square kilometer area would not take more than a day to survey each and every square centimeter area, both elevation and things, and which most of the institutes and IITs or research institutes, they are having all this LiDAR camera as well as software. It is not unknown. So getting a more bigger scale things and then customize the rainfall related information, what will be the inundation, sophisticated software that which have been taken. So they have to be customized now in this manner. So, okay, just only I would say that when we are having the flooding like this, see that two-lane road has been converted to 1 lane, maintaining the lifeline between the connection from that side to this side. What it is a geotube, geomembrane, filled up with water only, and then stop water for say ½ meter or 1 meter by creating such kind of, we call it say aqua dam or whatever it is. And not only this, even in our locality, local area where water is there, rainwater, storm water is there, you see that how polythene is being used, urethane kind of material, which is a petroleum byproducts, which are available in the form of geosynthetics, that how they stop the water from one side to another side. This is all information are available. So, and not only this, that how to stop water in this manner. We can create some kind of example here, buy these things available in the commercial market and create our own way of mitigation in our area. And what they do, these are the materials we know very well. Flood sucks is a commercial name. Or even this kind of scenario also soaks up oil and many things. So, and also you can see what kind of measures even in our household inside also can be made. So it is how to live with the flood. Lastly, I would say that those who are from Banaras, I think Pandey Saab is, he did his masters from BHU, and you can see Lahartara Lake. You please visit there. What it was and what it is now. Have you visited recently?
Yes, sir. Durga Kund I have visited recently, sir.
Huh. So, ye lake, what it was like this.
Yeah.
And it has been made into this now in less than 3 months of time. Who has done? How it is being done? How much money has been spent on? And how it is made possible? Let our students, teachers, community, everyone come forward, not to challenge that what they have done, rather take an observation that how naturally water has been cleaned from this stage to this stage. Not only that, because it is a course is for drought and flood, and here that water, whatever is the water capacity, carrying capacity of this lake has become double now, because this methodology of natural cleaning helped this reduce this kind of, you know, what do you say, this solid, semi-solid materials, they have vanished. They have just vanished, and water has become lively, fishes and everything has been born. And moreover, capacity, whatever, it is more than 2 feet, more than 3 feet, water level has come down. So when we are drought and flood and drought, and whatever analysis or whatever study that we are making in our universities and colleges, let us make, these are the practical examples of for the students and for the new generation to see that not to fit any equations or any kind of mathematics here, no hydraulics. It is simply the wonders that nature has been doing. So now I think I have taken more time, but I would like to show one of this, that which if you have not seen, let me show this video, that how to make a predictions or early warning. And it is made in 2004 using Google Earth at that time when it has started. I think video is, you can see the video?
Yes, sir.
Okay. And sound will be coming. Oh, sound is not going there. Can you hear the sound?
No, sir.
No.
Okay. Okay, let me. Now you can hear the sound.
Yeah.
See that a scenario that synthetically they have made a scenario using Google Earth. Google Earth, who doesn't know? But creating a scenario like this synthetically, an landslide may happen where we call it block or whatever it is, and we have been noting so many things are happening, and we are blaming so many things and putting this reason, that reason, and this much of conference, seminar, everything. But academics, research, we have to come forward to simulate one such things. Like here, we do not have any control on such kind of things, especially when earthquake happens, or when, and especially when this kind of dam has been formed. So what will happen if it is raining, or even glacial water is coming? It will create a dam like this. When this is the dam, someday it will breach. So you see, breaching part also has been simulated. Now, what will happen? Let me. You can see that breaching will take place. By the time we understand that we are helpless, hopeless, hapless, and then we start frightening this, that. Where is our rudder? Where is our Doppler rudder? Where is our CWC? Where is their stations or rain gauges and all these things? What happens to them and how they are able to customize this information to the public when this water is coming, and what are the bridges or culverts and other things are there. So that, and what will be the impact on those bridges? You see that these bridges is there. So what kind of effect will be there? What kind of effect on the barrages are there on its way? And then how far that it is going to inundate, where it is going to bifurcate, and then what kind of impact will be on the existing establishments. So we can do all these things. It is not that we can play with the software and just take the measures and keep on only playing the games kind of things. It is something like that. Our public and our projects, where a lot of big projects are going on, and they have to be guided, aided, helped to see the resiliency of the infrastructure, which are so many infrastructures are coming up, either in the plain area or in the hilly area, wherever we are. So what kind of simulation, what kind of precautions, like this portion, it is coming out. So we have to make certain kind of bond or embankment or levee, something kind of that, so that water should not come in this way. So such kind, and you see, when this water is entering into our own locality or area, and then how much time that it is going to take to inundate the everything, which commercial softwares have been able to customize and giving it. But giving a live information of where water can pass through, where what kind of bond or embankment have to be made, and when it is coming to our own locality, and what sort of precautions, like this car, if warning would have been there. You see that in Japan, that where they put the dark box, I mean post box, these days they have become obsolete. But you see that what is the live simulation that where we can do. For this, no LiDAR data, no survey, nothing is required. It is simply an animation and sophistication. And so such kind of things that has to be cooked up with the so much of data that we are playing with. I think enough. Let me thank you and end it here.
Thank you so much, Professor
Dr.
Chandan Ghosh, sir.
Pramod.
हाँ sir.
Let us invite to Dr. Prabhat Singh, Professor Prabhat Singh.
Yes sir, yes sir.
For 2 minutes, his comments or views, very briefly, he can.
Exactly sir, exactly.
Because he is there.
PK Dixit sir, we would request you to say a few words, sir.
Professor PK Singh Dixit sir.
Yeah.
आवाज unmuted.
जी जी, आपको आपकी आवाज आ रही है सर, आपकी आवाज आ रही है.
Wow. Thank you, Dr. Chandan Ghosh. It's now time that I'm able to see you. Yeah. During my studies, you were working as faculty in ITBHU. Hello. Am I audible?
Yeah, yeah.
So definitely, it was a very interesting presentation of the chief guest, Dr. Chandan Ghosh. And definitely, we will like to collaborate with each other to make this platform more viable. Okay. In near future, definitely let us collaborate and do some real work in real sense. Thank you.
Okay.
Thank you so much, Dixit sir. So before moving forward, I request if any participants wants to give your feedback about the course. If they want to speak something, they can raise hand and say something about the course. We would love to hear some feedback from the participants, because you have been with us for last 5 days. So it would be nice if you can share some thoughts about the course, about the weaknesses, about the strengths, about suggestions for improvements. Anyone wants to say something? Because we have seen that the participants have been really active in the afternoon sessions. For the lab sessions, they have really been very active, asking for every 1 minute they were asking question like at what step what should be done. At every step they were following things and doing all together. So we have really seen such a active participation during these courses. So somebody may want to speak something. They may come forward and say a few words.
You can raise your hand and we can allow the mic or enable the mic. If the mics are not on, then participants may
Yes,
raise
yes,
the hand.
they can raise hands. Okay. Anyway, so we have forwarded the feedback form to all the participants, and related to certificates, SK Pandey sir has already mentioned that the certificates will be provided to you in 1 or 2 days, and we are gathering the information about the certificates, the correct name and the institute name, etc. So that will be done via Google Forms, right? So sir, shall we move forward with the ending of the session with vote of thanks? Or you want to say?
I invite Dr. Pramod Soni, who is a very dynamic and very active, one of our coordinator of this 5 days training program on this drought and flood. One participant has raised the,
yes, so let's take that.
Listen. Please,
Yes,
Virendra
please,
Kumar.
Virendra.
Yes, sir, I am unmuted now. Thank you, sir. Sir, I am Virendra Kumar Thakkar. I am Assistant Professor in Computer Science and Engineering from GV Pant Institute of Engineering and Technology, Pauri Garhwal in Uttarakhand. Ours is an area, Uttarakhand, which has natural calamities like landslides, earthquake, even floods. And we have witnessed these disasters in earlier 2013. And again, from time to time, these events are happening in other parts of Uttarakhand. So I have been participant in many of the programs conducted by NIDM, but this is one of the unique sessions where NIDM as well as MNNIT have come together and joined hands to say for this area. And I, as a computer engineer, particularly, I got to know many new concepts like modeling, advanced applications, how we can say have better forecasting techniques. And this earlier I thought that it is just domain related to civil engineering. In fact, we have even in IIT Roorkee we have separate department of earthquake engineering. So while teaching statistical modeling and queuing theory to my students, I have always been telling my students that these two are the most unpredictable and difficult, even for supercomputers. First is the weather prediction, and second is the earthquake prediction. So this floods and this area is very much related to this modeling and many advanced techniques I came to know. So I'm thankful to all the organizers. Thanks to all the eminent speakers for sharing their knowledge with us. I came to know a lot of new things. All the presentations were very good. And I hope we shall get all the recordings also. And it was unique in the sense that I have participated in many 1 day and 3 day sessions of NIDM, but this one is 5 days and very long. That is 10 to say 4 p.m. almost every day. It was full FDP, and particularly in the afternoon sessions, there was very good hands-on training sessions. As far as the platform is concerned, I don't think MS Teams is that good platform, particularly joining, and sometimes these are technical problems. So there should have been some better platform like Zoom meeting or maybe, but considering the number of say participants and maybe the due to licensing restrictions, etc. So personally, I didn't face any problems in joining the meeting, and even sometimes I was able to take phone calls in between. So it was very comfortable and no problem at all. It was very good, but there should be better platform than this in future. That is what is my suggestion. So once again, I thank all the organizers and all the eminent speakers in NIDM. Of course, I'm familiar to most of the faculty members I know because I have listened their many sessions and their presentations. So I know most of the faculty members by faces. Here, Professor Chandan Ghosh, and I have listened to many of his sessions. So these sessions on flood modeling and these were very relevant and very useful to me. Thank you very much, sir. Thank you all.
Thank you so much, sir, for your kind words and suggestions. Actually, we'll try to incorporate that in the future sessions. And as you rightly pointed out, that one of the issue was the licensing, because our institute has a full license for the MS Teams, but we don't have license for the other software. So maybe in the future we'll try to incorporate
Even
that.
we are using MS Teams for our
exactly,
for online classes.
for the
So
classes
I
and
was
all, we
familiar
use
with this
that.
platform.
We are comfortable with that. We know that it takes a lot of bandwidth, etc. So we have faced these issues.
Yes.
Yes, we know
Very
that.
resource
So
heavy, sir. Consumes a lot of resources.
Exactly, it takes everything. So we will try to improve on that perspective. We have also felt that since so many issues were there. Him Pushpaji, ma'am, I'll just allow your mic, please. We have one more participant. Ma'am, you are unmuted, please.
Hello, good afternoon, everyone.
Yeah, good afternoon, please.
Actually, it was a good session. I liked majorly the hands-on session, which is more important because listening to lectures is different, but practicing on the same thing is very different. So that was the best part. And the weakness, what I would like to say is the network issues, which is also understandable. This is because of online session, but don't mind it, but I would like to suggest that people, those who are joining, either their senior lectures, senior professors, or whosoever, they should at least once try how things are going to be done on online platform, because when the session is running and they're putting problem that this is how to do that, how to do that, so it's my suggestion that sir, please go through once before, prior to the session starts, so that will be beneficial, and that will not waste time, I guess. So that's it.
Thank you so much. I understand that concern also, because this technology is improving every day, and when people are at some certain age, so we are not used to that much technology. It keeps on changing. When MS Team first came, there were not many features. I mean, I was also learning, but whenever I learn something, within 15 days they change the feature, and so it's like surprising for us also. So we'll improve on that aspect. I understand. So technical assistance will be required in future courses, so that will be taken care of. Thank you, ma'am. Thank you so much for your nice suggestions, kind words. Anyone else want to say something about the course? We'd love to hear from participants, because that makes further improvements in the future courses. Okay, so Pandey sir, so in case we have no further feedback, so shall we move ahead for the vote of thanks and then conclude the session?
I invite you, Dr.
Yes,
Pramod, please, last but not the least, please propose the vote of thanks.
And yes, so once again, very good afternoon to all of you. On behalf of the entire team of DAM 2022, I once again wish to extend my gratitude to everyone who has directly or indirectly contributed to this successful conduction of this entire 5 days course. So first of all, the driving force behind this short-term course, organizing this short-term course, is motivated by the vision and interest of our esteemed honorable director and patron of this course, Professor R.S. Verma sir. So we are grateful to him for his kind support and encouragement. I wish to express gratitude to the most important pillar of this course, Sri Taj Hassan sir. He is the Honorable IPS Executive Director at NIDM New Delhi. Without his support in all the aspects, be it financial or technical, this course would not have been possible. We are really thankful to you, sir, for providing such a major support to this course. But we are highly indebted to our chairman of this course and the head of the civil engineering department, Professor P.K. Mehta, sir, who has always been a constant source of inspiration and motivation for us so that we can carry out all these activities. We are grateful to our co-chairman of this course and head of the GMR division at NIDM, Professor Surya Prakash, sir. His continuous support and suggestions at various steps have really been helpful and constructive to improve the course. Further, we are grateful to all the resource persons of this course, both external and the internals, starting with Professor P.K.S. Dikshit sir. He is present with us. Thank you, sir, so much for being present here and sparing your time. He's from IIT BHU, Professor S.P. Rai sir and Professor K.K. Pandey sir from BHU, Professor Chandan Ghosh sir, again, he's also a chief guest of the session, Professor Surya Prakash sir, Mr. Anil Kathat, all of them from NIDM, Dr. Himanshu Arora from NIT Jaipur, Dr. Istiaq Ahmed, Mr. Amit, he was the PhD student and one of the hands-on session, and Dr. Vikas Kumar Vidyarthi, they all from NIT Raipur, Dr. Hemanta Medi from Tejpur University, Dr. Sudhir Kumar, sir, he was from Allahabad University, and further our internal speakers, in-house speakers, Professor R.P. Singh sir, Professor R.M. Singh sir, and Dr. H.K. Pandey sir, we all from MNIT. We are really thankful to you. Without your valuable time, this conduction would have not been possible. We are thankful to our student coordinators again, Vishal, Swapnil, Ramraj, Swapnil specifically. He was really active throughout the course for helping us in the crucial activities of this course. We thank all the deans and heads of the various departments, faculty members and students who have made this event a huge success with their presence. Once again, thank you all. And last, we'll now stand for the national anthem. So I'll share the PPT sir once again.
Pramod,
yes, sir. Yes, sir.
Let me thank you because let me inform to the participants as well as guests, distinguished guests who are present here at this occasion. Certainly, from the bottom of my heart, I convey my sincere thanks to Dr. Pramod Soni because without his involvement, his involvement was such I cannot narrate in the words. Participants would have already realized this. I hope they are realizing it. That right from the beginning, whatever the problems by the participants were raised immediately at the earliest, or it has been replied by Dr. Pramod Soni. So although we were coordinators of this program, but without involvement of dynamic and thought-provoking input in this 5-day training program, I believe that it would have not been possible. So from my bottom of my heart, I convey my sincere thanks, and I hope we will do in such type of training program in future also. With these words, I thank to Dr. Pramod Soni. Now you continue.
Thank you so much, sir. Thank you for kind words, sir. So now I
would also take this opportunity to thank from NIDM side on behalf of our executive director and also Professor Surya Prakash. So thank you to your entire team and especially your director. That all the wonderful work and motivation that you have done, especially during holidays, that 4 days holidays that you have utilized in this manner. So Jago India Jago. Huh? So
thank you,
it is a really wonderful job that you have done, and it is from the bottom of my heart also. I sincerely thank you for taking our mission towards disaster mitigation, especially in the special area of drought and flood analysis part, as well as hands-on training has really made us also really helpful, and we also feel really proud that with more and more such programs that we do jointly, even in hybrid mode or online mode or even physical mode. Most welcome to Delhi and visit our new campus here in Rohini, where I'm sitting. We have shifted here 1 year back. So please don't hesitate to calling us whenever you visit Delhi physically. Thank you.
Thank you so much, sir. Thank you, sir. So shall we move for the national anthem, sir?
Yes.
Share the PPT. So we stand for the national anthem now. तव शुभ नामे जागे शुभ आशीष मांगे गाए तव जय गाथा जनगण मंगल दायक भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे. We can end this now, sir. Thank you, sir. We can now exit the meeting. Thank you.
Sir, pranam, sir, pranam.
Pranam. Okay.